All right, so we got a chance to work around and play around with some of the editing tools as we were finishing up yesterday, and um, we've done a little work with some points, but sort of haphazard. We're going to sort of jump back over to the the points section so we can do we're going to do a quick exercises on points and point groups, just so you know how Carlson points can be of help. We've done a lot of that stuff already on the points part. So let me get to this exercise. So just go ahead and start a new drawing, call it anything you would like. And you can call it class example 3 if you're following suit, however it works. And so once this comes up, chance to settle. There we go. Get a new drawing. And I'm going to hit the set button for the drawing. I'm going to go to the fundamentals class that we were yesterday in that folder. I'll call this one class example 3. And I'll just take all the defaults on that. And same for that. Okay, so I've got an empty drawing. I've got things started up. Um, One thing I want to point out before we jump into this are some of these toolbars that are out here that I find very helpful and useful. We talked about setting up this properties window and sort of docking it on the side. Now, on the Windows version, there's some slight differences. I'll go ahead and start that up just to show a couple of things. All right, so let me go ahead and set this. And I'll just call it junk. But it'll be in the right folder. Now, so there's a couple of things. I've got basically the same layout established here in the AutoCAD version as I do in the IntelliCAD version. But here there are a couple of things to point out that are potentially different. There is here, I'm in the IntelliCAD version right now. And if you look on the view menu, and right down here in the bottom half of this view menu, there's all of these things that govern your layers and how you can isolate layers and restore layers, freeze them with a pick and all that kind of stuff. And that's a very useful toolbar. It's also up here at the top. Hold on a second. I keep forgetting to do this. Yeah, so up here at the top, there is a toolbar that has these same commands on it. You see those icons there, that means they're on a toolbar somewhere. So that's that Carlson layers toolbar. Now, there's one of the things that we do quite a bit of is we set our layers. And so we're going to use this thing called layer control. Now, here's the difference in the two versions. When I choose layer control in IntelliCAD, it brings up something that looks very similar to the AutoCAD version as a layer. Thank you very much. Just had my hot tea delivered. That's service. I appreciate it. Thank you, hon. All right, so So this is very, very much the same. When you set your layers and colors, you got these buttons up here. You can make a new layer and you can save layer states and all those kinds of things. And that's called your layer control from the view menu. And on the AutoCAD version, if I do that same thing, view layer control, it opens up this palette. AutoCAD has layer properties manager as a palette. And you notice it's very similar, has the same type of uh, layout with, the layer assignments and filtering and all of that. But it being a palette, it can, as opposed to a window that opens up, it's a separate palette and it can float and dock. In fact, I keep mine set. If I right click in this title bar, I tell it to auto hide. I don't allow it to dock. So I'm just gonna let it float, but it auto hides. So when I move the mouse off of it, it goes away and it's just this thing. And I just sort of stick it over here on the left-hand edge. And anytime I need to work on layers, I just pop over here and hover and it pops out and I get back off of it. I have the same thing with this external references palette over here on the right when I do XREFs. Okay. So that being the AutoCAD version of this same thing. But see, this is not a dockable palette. It's something that you run, then you close. However, there's a lot more to the IntelliCAD thing when I say layer control. It brings this window up, but this window is not just layers. Look at the title of it. It says Explorer, and I'm looking at the category of layers. Over here on the left-hand side are my categories. So I'm right now sitting in layers. If I look at line types, these are all my loaded line types. If I look at text styles, these are any loaded text styles. Right now, I've only got standard. I can make a new text style here. I'm going to do that called PTXT. Excuse me. Uh, and I got to find the font over here, and I want to use Calibri Light. All right, so I've got that set. So you can control all kinds of different things from this one interface, this thing called the Explorer. I can even look at, here are my XREFs. If I want to externally reference a file into this file, I can do it from here. I also still have, I'll go ahead and close this. I also still have, if I run the XREF command, I've got this separate little XREF window just like the palette in AutoCAD, and that works the same way. But you can do a lot of things from that layer control panel. And it's right here in this toolbar, which is called your entity properties. That thing right there that says layer control. When I choose that, it launches that very same thing, like the view menu, layer control. And again, goes to layers. But again, you've got all of the blocks that are defined, dimension styles, groups, layer states, layers, layouts, line types. You get the idea. Okay, now here's why this is useful and why I wanted to take the time to point it out. I'm going to open up two more files. I'm going to open our sample from T3, and then let me open, let's just go up to a different, drawing here. So this is, for mind management kind of thing. Now I've got three drawings open. So let's say I'm in my drawing and I go, man, there's some layers that I've got set over in this other drawing that I want to get to, and I want to copy them into my drawing. So what you do is you run that layer control. Now it can also be layers, it can be fonts, it could be anything. So I've got layers, but now notice in this category, I now have a drawing file name, and the one that I'm in currently is bold and it's expanded. I've got these other two drawings. Here's sample from T3 Global, and here's my underground pillars drawing. They each have their own. Now, I can share things back and forth between all of these drawings. So if I go to my samples from T3 and I see some layers in here that I might want, let's take all of these V topo layers. This will give me all of that topography that they've got, okay? So I'm selecting them from out of this drawing because I clicked over here after I expanded it. Now I'm going to take these and drag them, and I'm going to drop them on the same category name in the drawing I want to receive it. Okay, so now when I go back to this drawing and I look at my layers, there's the ones I originally had, and I now have just inherited those from the other drawing. I can do the same thing with other items. Like here's some text styles. I've got standard and Roman simplex. Let me look at this other one. What might be in there? Text styles. They have a mono text style. So if I take that and bring that over into, well, that's the wrong drawing there. Let me get back to, there we go. Put that into my text styles. I've also got blocks, all of these individual blocks that are used as symbols in that mapping file. I can take those and drag them right into mine, okay? Looks like they've got this underground pillars as a separate block. Okay, so you can share, and you can not only share that, but you can share these paper space layouts. So if you have like title bars set up and different paper sizes and such like that, you can drag and drop layouts in between these different drawings. Okay, so that's that functionality in IntelliCAD that you get to from what looks like a command that's just going to talk about layers. It's called layer control. Okay, but that runs this IntelliCAD Explorer. Now, not to fret, we have a similar functionality, just not with layers and text styles and all of that in AutoCAD, but we have this palette that's called, I think it's called DC for Design Center. Yeah, D-Center. Okay, and so this lets you open. So if I go, if I've opened up, let me open another drawing. I'll just open the one extra drawing here. So now I've got these two drawings. I've got my empty one. I've got sample from T3. And so I can go now to this design center and I can have these, again, same type things. I've got blocks that are in view those as large icons. There we go. So I've got these blocks that were in that drawing. So I can just, now I don't drag it and drop it here. I drag it into the drawing like that. So they're now, let me turn this auto hide off. So they are now also in, whoops, let me see, did I miss them? It says it's not. For whatever reason, the blocks aren't going. But you can do things like that with the layers. Here's all these different layers. Now let me just look at a list. So if I take these VTopo layers here, oh, I think, well, no, maybe not. So now if I take that and just drag them into my drawing, I look back in my drawing layers, now you see they've been added, okay? So you've got this same thing. It's called Design Center, or DC. We'll bring it up, or D-Center. So you've got that same functionality, just works slightly differently. So that's just a couple of handy things that you've got. Like when you do your text styles in AutoCAD, do this command, this style command. It's also available on the draw text menu. It's where you set these particular text styles that you're going to use. Over here over here in IntelliCAD, you've got that same functionality, draw text, set style, and it brings up that very same dialog box where you choose the style you're going to work on. See, there's that mono, and you choose a font and all the characteristics about it. Or you can do it from this interface that we talked about with layers, and there's your text style, and there's your different ways to set those up. Okay, so just a little differences in the interface and why and how you may want to have some up. So let's talk a little bit about these toolbars because a couple of them are really, really handy. Predominantly this one right here that I'm hovering over the little handle on the left, and it tells me it's called layers. And I use that a lot, and I use this one over here a lot called polylines. And I also use this one over here called inquiry. Oddly enough, the one command I use from this toolbar more than anything else is this standard distance command to measure distances. Some of that other stuff I don't really use much. I've got some things floated here, like there's my help toolbar. Um, there's my grading. These are my O snaps or entity snaps. Those are those little snaps that we talked about using yesterday. This down here is my Carlson menus that lets me switch between modules. And then up here's one I use quite a bit. It's my surface toolbar where I can run the commands that make the surfaces, and I can view the things in the drawing or view a surface and also do a surface inspector kind of thing. So a lot of commands here that I may not use all the different commands on the toolbars, but the ones that I use most often are that uh, surface, layers, polylines, and it's really about, and then over here I've got the draw commands, and on the right-hand side, I've got the modify commands and the transparent commands. Now, here's how you get to them. Up in, you can either do it one of two ways. You can go to the gray, just any blank spot in the top of the window and right-click, and in IntelliCAD, you'll see this type of menu that comes up, and you'll see that's where you can switch to ribbon or back to menu bar. This command bar, that's the command line at the bottom. The status bar, that's the bottom line with all the little icons on it. But you can see down here, there's a show menu, which lets you pull different menus. Now they're all being shown. Or you can show toolbar, and they have different categories. There's Carlson toolbars. There's C and G survey toolbars. That was that survey subsystem. Don't use much from that. There's the IntelliCAD toolbar. So it has its own separate toolbars. And then there's the IntelliCAD in DGN mode for MicroStation files, and it has its own set of toolbars as well. So here's the ones that I use under Carlson. You can see they're here. You just pop that up and check it, and there's a little arrow down here at the bottom which scrolls. I'm going to show you an easier way to find this in a minute. And then from the IntelliCAD toolbars, I only use draw, snaps, and modify. And those are my standard CAD tools, okay? So here's the easier way to get to all of that is under settings. If you look at your toolbar setup, it's about midway down, you can see the same type of interface showing here. And here are your different categories. It's sort of hard to, it's easy to miss that, but there's my Carlson toolbars. And here's the one I have for Carlson. I've got my Carlson menus, and that's because I have multiple modules, and that's the one I've got using there. I've got the draw commands, and that's this vertical one on the right hand of the two vertical toolbars. And those are my Carlson draw tools because that lets me choose the Carlson versions of these draw tools. I also keep out over here beside it this IntelliCAD draw toolbar just as a corollary, because sometimes I don't know, there may be an occasional thing that's easier to grab from that toolbar than this one. Probably not. Like there's a draw point tool, and we don't really have that one over here, but it's just there out of habit. And then likewise, while I'm still here in the IntelliCAD set, I've got these entity snaps and I've got the modify tools. And those are these over here on this long ribbon on the left. Things like explode, trim, break, rotate, copy, move, offset, things that you can do with other ways, but the toolbars makes it convenient. So I'm going to go back to Carlson and show you what I've got there. I've got my Carlson menus. Again, that's that. Draw, that's that vertical. Entity properties, and that's this one right here that lets you set the layer, the color, the line type, the line weight, and it also has that button that invokes the layer control explorer. Okay. Then I also have grading, which is this one, or not that one, but this one over here that lets you set elevations and such if you're doing grading design. Help, which you don't really need. You can pull that from the help menu. It's just I just usually keep it there to illustrate a couple of things. Inquiry, again, the only thing I really use from that is that standard distance command. Just again out of habit. And then layers, and that's this one, not this one where you can pull down and set the layers for the entities, but it's this toolbar here where it has the controls like isolating and restore layers, freezing and thawing layers. This one particular command right there that you see is a pencil eraser and a stack of layers. That's called erase by layer. That is one of the most useful commands in the entire program, and it's really easy to get to from the toolbar. Otherwise, you have to go to the menu, you have to go to the edit menu, choose erase, go to the right and choose erase by layer. Okay, so then a couple of others that I also keep out, polylines. That's the big one that is useful because it has things like remove vertex, add vertex, remove segment, things that I do all the time. Reverse direction, join up polylines that have the same or nearly the same endpoints. Different things that you can do, but they're buried like 5 levels deep in the menus. So they're good to have. Then this standard toolbar is this one that you see across the top with the new, open, save, print, all that kind of stuff. It includes undo and redo. And then surface, there's sort of the things that I can do from the surface menu, and it puts the viewers, and those are really the two commands I use mostly. The view 3D or view objects in the drawing, which is that little tricolor cube, or view a surface file, which is that little one, two away from it. The one in between that lets you do a flyover. Kind of a cool little effect, but you know. And then I've got these transparent point commands, and that's this vertical toolbar on the right, the little short one. That's where you can interrupt a command and do things like, find the centroid of an object, or do a distance intersection, or a, bearing distance, whatever, to just sort of compute something on the fly in the middle of doing something else. So useful commands to have. So Carlson menus, if you have multiple modules. If you don't have multiple modules, no need to waste the space. Draw, entity product properties, grading, help, which I don't normally would not have that out there, but grading, inquiry, layers. Layers is pretty important. Then polylines, also pretty important. Standard, again, pretty important, helps you work with your files and your undos and redos. And surface and transparent, less important, but I keep them out there. Now, that's what I have from Carlson. Under iCAD, these are the IntelliCAD menus that I have out there. Now notice I've also got a draw toolbar. That's this one that's right beside my Carlson draw. I've got entity snaps. Those are these snaps that up here that I normally just hold the shift key and right click the mouse if I want to turn these on and off. But I keep that up here mostly for class purposes to illustrate them. And then the modify tools, which are over here on the right, this long string of standard CAD editing type tools. Now notice they have, for instance, a layers and a layer tools. So I'm going to pop up layers, layer tools and layers, and this is from IntelliCAD, and I'll just show you the difference in them. If I can now find where they went. My entity snaps. Here's my layer tools, and let's see where they put their layers. That's help. I'm going to turn my help toolbar off. And let's see what have I got here. This is grading, entity snaps, entity properties, layers, but that's Carlson's layers. Oh, it's right here, hiding in plain sight. All right, so these are IntelliCAD's layers. Now, notice this layers toolbar for IntelliCAD incorporates these entity properties tools, like where you can choose the current layer that you're using, but it also lets you set the current layer by picking an entity. You can go to the previous layer, you can choose your layer states manager, and you can run this explore layers tool, that same thing that we saw earlier. Okay, so under here, under these layer tools, you've got layer match, layer current, isolate, and isolate and freeze it in a viewport. You can unisolate, freeze a layer, thaw a layer, turn it off and on, lock and unlock layers. So that's using the standard CAD tools. Now, Carlson had all of their tools to do things like isolate, restore, freeze, and thaw. They were built long before AutoCAD or IntelliCAD, long before IntelliCAD existed, but even before AutoCAD gave you those types of tools. So that's why they had that separate toolbars. And I've just gotten used to using them. So all of that's entirely up to you, entirely your choice on anything and everything. I think, let's see, does IntelliCAD have a standard? Yeah, see, IntelliCAD has a standard toolbar as well, which if you compare that one to the one that I use from Carlson, which is up here, looks like it's got new, open, save, publish, and print, which I've got new, open, save, print, and print preview. Check spelling, they got check spelling. They've also got a find. There's a cut, copy, paste, match properties. Again, those are also all on mine. Undo, redo, and then there's a delete and a clear the drawing. Not sure exactly what that does. Deletes everything in the drawing. And then access to the help menu. So there's a couple in here like this clear drawing, uh, find and replace that are not on my Carlson standard tools. So either one would work. They do all those same types of things. Okay. So that's the interface if you'd like to use those kinds of things. And the reason I do it, if you look up here on my polyline, here's a command I use all the time. Right here, it says remove polyline vertex. And once you get used to where it is and what the icon looks like, it looks like a polyline with one of the vertices is red and there's a pencil eraser hovering over it, getting ready to remove it. Same thing here is remove polyline segment. Okay, so that's a much easier tool to use than the pedit command, or even if you're just hovering over the grips and deleting the grips. But to use it, it's buried. It's under edit, polyline utilities, remove polyline, which does not mean erase the polyline. It means these are remove tools. These are edit tools. Here's remove tools, and then you can remove a polyline vertex. So you see it's a click, pull right, and then find it and land. So it's a pretty extensive effort to do that. You can see on the status bar underneath there, it tells you what it does, removes the user specified vertex from a polyline, colon, and then it tells you what you can type, RMVERTEX, to run that command if you'd like. But here's the key. When you see an icon next to a command in a menu, that tells you that it is on a toolbar somewhere if you want to use the toolbars. It doesn't tell you which toolbar it's on, but if you see that, now notice this remove polyline arcs, there's no icon for it, so it doesn't live on a toolbar anywhere. So here's one, remove polyline vertex, which again, I use a lot of. It's on a toolbar. I don't know which toolbar, and you can sort of search around and find it, but there's an even better way of doing that as well. It says remove polyline vertex. So I'm going to go up here instead. I know the command I'm after. So I'm going to go to the help menu and I'm going to choose this command search. And right now it's like every command in the world that it's got knowledge of, but I'm going to type remove polyline. And there it is, remove polyline vertex number 217. And I see what main menu it's under, edit, it's under remove polyline submenu. It's available to all modules. Here's the keyboard command, and there's the toolbar that it lives on. It lives on the polylines toolbar. Okay. Same thing as erase by layer. There's that command. And it's available under edit, erase, and then you choose it from that submenu. There's the command you type. It's also available under the toolbars, and it's under the layers toolbar, but the Carlson layers toolbar, not the IntelliCAD layers toolbar. And there it is right up there. Okay, so it's not part of the layer control stuff, but it is available for layers. And there's that command, erase by layer, where you can have all kinds of great functionality. All right, so just a couple of things to help you navigate your way around the system. Now, let's go back and talk about these points and how they are used most effectively. So Carlson points, we've already talked about, are not the same thing as a simple CAD point. So if you remember in my in this aerial mapping file, there are a bunch of CAD points, these purple looking things here that are part of that file. They're just so small you can't really see them here in the main drawing. So with that, and close this off now. I don't need to keep it open. So with that, with that distinction, a Carlson point is not just a CAD point. It has a CAD point in it, but it also has those other two blocks, and they're treated as a group. It has a graphic block, which is the symbol, and it has a block of attributes, which are the point number or name and the description or the elevation and the description. So those three things, the two blocks, the one of the labels, the one of the symbol, and the point itself all compose a Carlson block, and they are addressed by number or by name if you're using letters in your numbering. All right, so here's how they help us out. If you go to, well, I mean, there's all kinds of other ways of doing it too. But let's go to our points menu and let's set the coordinate file. So right now we've got an empty coordinate file that's the same name as our drawing, but I'm going to set a coordinate file and I'm going to make sure it's one of my existing files here in my folders. And let me sort this accordingly. There we go. And the one I'm looking for is exercise 1 coordinates. We looked at that a bit yesterday. And all you're doing now is saying, hey, this is the coordinate file I want to work with. So to see what's in it, we'll go back to points and list points. We'll list them all. And you'll either have 22, or if you're continuing from all that other stuff you were doing yesterday, you may have those extra ones. That's fine. Okay. So I've got the original 22. And if I want to put them in the drawing, I need to go to points and do a draw locate, which means draw means read them from the coordinate file and put them in the drawing. Locate means to create a point in the drawing. So all kinds of controls here, whether you're going to use these various parts of it. You can set a different symbol. In fact, let me, just for yucks, let's see. Yeah, so you can make a point with a symbol like this. It doesn't have to be these particular points, but don't lose track of the fact that there's a pull down category up here in the top, and they can be some things that are very useful. Inlets and manholes, for instance. So, make it suit your needs. Right now, I had that little plus mark or an X mark, so I'm going to switch it to, let's use these triangles. All right, so, and you get some different things here. Now, this starting point number doesn't mean that's the point number it's going to start with if you choose to draw them. That's if you're creating new ones. So it goes to the first available empty number and puts itself there. And you can type a different number like 101, 501 to start off a new sequence. You can also limit your descriptions here with the wildcard. You say if you only wanted to plot your control points, you knew they all had a description of CTRL. And you got hundreds of other points and you don't know which points of control, you could just put in there CTRL or CTRL asterisk, meaning points that start with CTRL and end with anything else. And then if you say draw all, it limits it to that wildcard description match. Okay, so again, there's your symbol size, your text size, the scalars. Think plotted inches at the scale you set. Here is the layer where you give it a layer name, and you could also say make a layer based on the description of the point. There's all kinds of controls, all right? So we're going to draw all and just let it dump in the drawing. And there they are. If you don't see them immediately, do a zoom extents, which again, you type Z, enter, E, enter. You can do it from the view menu, or you can double click the wheel on the mouse. All right. So I now have some points, and you notice, remember, I did these little descriptions yesterday as we were playing around. So that's why some of them are there. But notice, I've got like, what is that? 6, 7, 8. Up there's 9. 10, somewhere down here there's 1, 2, 3, 4, 5, 6, 7, 8. Okay. So you got points 1 through 22. Here's why using points, and if you have points, that makes it really a lot easier to draw with. Let's just draw a 2D polyline. I'm going to choose it from the draw menu. 2D polyline, you see the icon. 2D and 3D. It's also on my toolbar over here. There's a draw line, there's a draw 2D polyline, 3D polyline, etc. And the reason I'm going to do that is because if I just draw a polyline, and a polyline means it's going to connect all the different segments, but if I just draw a polyline with the standard CAD tool, which I can do, it has no awareness of my points, but Carlson commands do. So the difference is when the CAD version asks you to pick a point, it wants you to either click a point or type a coordinate or snap to something. And when Carlson asks for it, it will say pick a point or a point number. And that right there is the key. So I'm going to make this polyline. And again, a bunch of controls. You can set the elevation by the starting point. If you have, you can have this autocorrect for 90-degree corners, like if you're drawing buildings and such. If you're close to 90, it'll force it into being 90 degrees. But keep your eye on that. If you have that on, make sure you turn it off if you don't intend to use it. All right, so I'll choose that, and I'm going to say, okay, now pick a point, and I'm in the command down here. It says pick a point or point number. So I'm going to just pick a couple of points. And now I'm going to start in by saying 3. So it goes up to point number 3. Then let's say 4, 5. Okay, and then I can go back to picking other points or snapping to things. And now, what's that number up there? 10. Now you can use a range. So I could say 10 dash 13. So it goes to 10, 11, 12, 13. Okay. And the range can even work backwards. So if I go, say, 21 to 16, I'll say 21 dash 16. So it jumps from where I just left off 13, it jumps to 21 to 20 to 19, 18, 17, 16. And then when you're done, you just hit enter to finish. Okay, so that's the real big ability of points, is with those point numbers to be able to use in commands instead of having to type them. Okay, so with that, now a couple of other things with points. When you see a point on the screen, you can do a couple of things. You can select it, and that brings up, you see in my properties box, and if you don't see the properties, right click the screen and all the way at the bottom, choose properties so that it brings it up. And again, I keep it docked over there. So you can select it. You can change things like the color and the layer that it's on, because remember, the layer that is on is what I had set when I did draw locate. So you can do all of those things, but you notice that it has 3 pieces in that group. There's a point which is different from these other 2 blocks. So the properties that are common to what you had selected, you can change there. You can change its elevation. So right now its elevation is 149.11. If I make that 150 and hit enter, notice what's happened. It normally, you've got other commands from Carlson that says change the elevation, but it asks now because I've changed it, and Joe's, yours may not have that thing. It may tell you can't find it. Update the coordinate file. I'll say yes. And it does. It updated the coordinate file with that elevation as one, or no, I'm sorry, not the elevation. It put it at elevation 150. And if I double click it, yeah, see there it's at elevation at 150. Oh, it did. It finally redrew. All right, so I had to double click it to exit. So you can change it there. You can also change something with an individual point. Just double click the point, and that brings up the editor. Now that has an elevation of 101.35. Let's make that 111. I hit enter. And then when I say okay, that'll change it there as well. And that does not prompt you to change the CRD file. It knows that you intend to. Now, a couple of other things in that double click editor. If I double click point 13, for instance, I see here I can change the point number, the northing, easting, the elevation. I can tell it how many decimal places I want to display out here. I've got it set to 2, but in my settings, my elevations, maybe I've got to 6. So I see the elevations all the way out to 6 decimal places, but I'm only going to display 2. That's what this next one is. And I have 2 different description fields, one for the drawing and one for the coordinate file. So I'll say, This is a test point in my drawing. All right. And I'll say, okay, and then that's what is displayed in my drawing. But if I look at that in my coordinate file, I'm just going to list the point. I see point number 13 right here still only says test. So if I were to redraw point 13, it would come back and say test. Now the reason there are two different descriptions is what is behind what's called field to finish when you draw things based on the descriptions of a point. So you might be out in the field surveying points and you put in your point description 12 oak, 18 pine, and you might have those descriptions set up. When you see a description that says 12 oak, I want you to write into the drawing 12-inch DIA period oak tree. Same thing with the pine, 18-inch space DIA period space pine tree. So it's a way of being able to take the actual code and generate longer descriptions so you're not wasting time in the field trying to type in what it is you want it to say in the drawing. That's why there's two different descriptions, and you only see that once a point is in the drawing. And if it's in the drawing, it gets erased and redrawn, it reverts to the description in the coordinate file unless you have on a particular switch. I'll show you that in just a second. The last checkbox there says non-surface. That means that, let's say you have a point and it has an elevation on it. Maybe you've got the top of the nut on a fire hydrant, the opening valve, and that's the elevation you're using. You might use that for a benchmark on a project. So that's your elevation, but you don't want to use that point in your surface modeling because it's going to be artificially, 2.5 feet higher than the ground really is. So you would mark that point as being non-surface so that even if you were to select it when you go to build the surface as part of that data, it knows to dismiss itself, to not include itself because it's marked as non-surface. Okay, so that's the reason we have that capability. Now, finally, the other things up here at the top, I've got different things I can associate it with it. That's how I can change the symbol. And again, you can either click the button and that goes right back to where we set that before, or hit the set button, does the same thing. You can have notes about a particular point. They can be recorded in the field and attached to that as well. It comes from a separate notes file. Here's a GIS tab that you don't see in this editor because it says it requires that CRDB format to be able to have it associated directly with the point. That's true, but it could also have GIS attributes in it that we can get at another way through a separate file. Then you can also have an image. You can add, like maybe you've taken a photograph of this to help, field crews find this point later, and then you can attach the image to that. And then finally, the settings right now are just limited to the decimal places for these values here. Okay. You can also look at the point history. Remember that switch we turned on to track your coordinate point history, where the drawing was edited with links on. I edited, and that was at that date and time. And it tells you the user who did that particular command at that date and time. So that, and you notice this undo through selected. So you can say, I want to keep that one, but I want to undo all the changes to that point back to this level. So that lets you get at that point history. Now, here's something to note for you savvy people. This comes out of a file that's named the same name as the coordinate file. In fact, I'll show you where that is. If I go to, let me find that file here. So we're in, let's see, so by type. There's that exercise 1 coordinates. But if I look down here for an HIS file, there it is. There's exercise 1 coordinates. I'm going to open that file. And here's what it looks like. That shows you, that date and what all was done with it. But here's the thing. That right there tells you who made that change. So, if you're really paranoid about something, maybe you've screwed up a project and you want to fix it, go in here and put your buddy's name in there, not yours. All right. So just saying. All right. So those are some of the nice things about points and how they're useful. They're also going to be used when we build surfaces, for instance. So surface building, when we make a terrain, considers everything that you select that has a non-zero elevation. So it's not only points that are out there by themselves, but any kind of 3D line work, okay? So it reads, let's say, and this is a 2D line right now, but if we draw a 3D line, I'm just going to do 1 to 22 so you can see it's all going to be different. So it overlaps in places here, but you can see the difference. You see the 3D line actually goes through all those points. Okay. If I had other things, maybe, and they were always points, but even if I had other vertices in this 3D line, so if let's add a vertex over here, we'll add another one over here, we'll add one here. All right, so there's now some different vertices. And if I look at that again in 3D now, you see it kept, when I just did the grip and added them, it just stuck them out there at the same slope as the previous leg coming into it. But the point being, when it goes to build a surface, and I select all this data, it reads the points, but it also reads all of the vertices of the line work. And if it has a non-zero elevation, it will use it. Okay. Now, if it could have a zero elevation, but being part of something else that has other non-zero elevations, then that zero elevation will possibly get included in that. So you have to be a little bit careful to make sure your 3D lines don't drop down to zero in spots. Again, another great reason why we use that 3D viewer. All right. So the points, like I said, can help us when we go to build our surfaces. And that's why when you think about surveying things out in the field, you get a lot of the edges, but you also get a lot of just random shots, ground shots or top of the pavement or, you know, grass in the field, whatever. So that's um, that's how points are going to help us out. And points are very much the means of choice of bringing observation data back into the office from out in the field. You can do, in fact, I did a pretty huge drainage project where we redesigned a lot of storm sewer system for a school district. I did the entire project without using the first Carlson point. I didn't use any, okay, because the base mapping, everything was given to me as a finished drawing. And everything else I did by snapping to features and, you know, what have you, and just reading the line work. So I didn't need the points. However, somebody at some position in the lifetime of in the evolution of that project, when they were making that existing base condition map for me, I guarantee you they were using some kind of points, whether it's Carlson or some other program, because that's the way they get the information from the field back to the office. When you go out in the field, you can't observe and bring in lines. You just bring in the points that you occupy. Now you can then later connect the dots and make them into lines, which is what they do. But again, you see points being very versatile in that regard because we can control them. And you have two different places for your points. You have a repository of them in your CRD file. You also have them potentially in your drawing. And they can be different. You can have a whole series of different points that were created in your drawing that are not in a particular single common coordinate file. Take the example of, let's say I'm a surveying company and I go out there and I make a bunch of maps for some things. But it takes me several days. I've got crews out in the field. And so day one, they come in, they dump their points. I may call that file day1.crd. I'll draw, locate, dump them in my drawing. Okay. Day two comes in, they've got another set of points, and I'll dump that in my drawing. So I'll call that day2.crd, and I'll bring those into my drawing. They can even be the same point numbers and be duplicates in the drawing if you allow that. Okay. So those are just things to keep track of. Just, do your own mental housekeeping on that kind of stuff. And again, that's quite common in the survey world. You'll have multiple coordinate files based on either a field crew or a date that it was collected, or some kind of designation that might keep those things separately. You can also merge them together. You can do all those kinds of things. I'll show you that command real quickly under points, these coordinate file utilities. Also reachable at the bottom, point utilities, or they're all separate. But if you just do it here, you've got two columns of buttons. You got things that work on files at a time. You got things over here that work on groups of points within your file. And see that command right there, list points? That's the very same command that we've done from the file menu. Right there it is. Okay. You can delete points, edit points, rename them, all kinds of things to get into. There's your point history. Okay. And there's for every point, not just that point 13. Double click point 13. There it is. It shows you drawing was edited. There's that name, Ken Crawford. So, you can track all that. And undo down through certain things based on a command or based on a point. So, all kinds of things you can get at from this coordinate file utilities. Here are your two updates. If the drawing is out of sync with the CRD file, you can update the drawing, holding the points in the CRD file is good, or you can update the CRD file, assuming the points in the drawing are now where they're supposed to be. So all of those commands, these are all individually reachable, but that's where they are. Here's where you can open up a different file, import and export points from one file into your current file. You can change formats, import, export text files, edit the headers. Again, there's just way more in there than it's time to go into. All right. So to finish this up now, we've got these points. You can see that we can use point numbers. Let's do this. I'm going to clear everything else. I'm going to just erase everything from the drawing. Okay, so I'm not going to be confused with point numbers. And let's go to another point example. Let's go to the points menu now and set the coordinate file this time to this one called exercise 2 point groups. Okay, and we'll choose that. And it looks like there's 68, or not 68. Let me see, points. Let's list points, list them all. So I've got 1, all the way down to 144. I've got, you see these descriptions over here, and they in this particular case, they happen to be in order. They're most usually not in particular types ordered. I've got some radius points and things like that. Some have elevations, some do not. Like all of the boundary points looks like they're down at zeros, but the buildings, there's some more zeros for edge of pavement. There's more buildings. Property corners have no elevations. Buildings have elevations. All right. So there's a bunch of things in here that might make it a little easier to manage if we, instead of trying to keep track of a range of point numbers, because if I wanted to draw all the buildings, well, I've got some buildings there, and I've got some buildings down here. So I don't know, um, without going and looking at this and keep track of point ranges in my head, I don't know exactly how to do that. So we're going to use point groups. Now, before I leave this little editor, I wanted to show you something as well. One of the reasons I use the Carlson report viewer right here, I've got, I can open up another file, save this file. I can append this file to another file that's already been created. I can edit, search, copy, cut, and paste. I've got some options here under settings, for instance, where if I, set the number of lines per page and what kind of font to use, et cetera, et cetera. But again, it's just a text file. Like if you wanted to cut out all of this preamble here, I'm going to say, let's take this out all the way up to there, and I'll just put a dot dot. So it goes data fundamentals class exercise 2 point groups. So there it is. I could take out this extra spacing. I could give it a title, do anything with it. Now, the nice thing about this, though, is if you need this information in your drawing, so you could take this and dump it into the drawing, and that would be under File, Screen, which is also, these commands here do the same type of thing. There's my print, there's my find, output to screen right there. Click. I can set the font, the heights, and all that kind of stuff. I'll say okay, and I'll just click a point here, set the rotation of east by just hitting enter. And now once you exit the viewer, there it is in your drawing as text. Double click it, and it brings up the MText editor. And at which point you can set the different fonts. Let's do that. Oh, Calibri. Except let's make it stick, actually. And of course, it's going to take its time. There we go. And again, it's just text. You can edit it. You can put it into a column. You can write, click all that, put it all into a table, et cetera, et cetera. And now it becomes part of your drawing. I think about this table. Table, edit table, export indicator. Yeah, I'm not sure. Anyway, there are some means of getting this into a table. We could also do from our standard old list points. And if instead of doing that, I use the report formatter, There's my display like normal. There's a spreadsheet view, which I could export to Excel. There's my HTML report, which is kind of goofy title-wise, format-wise, I mean. Table entity, that's what I was looking for. The table information is saved, will be created upon exit. So when I exit and do that, pick a location, I'll just pick it right over there. And I'll say okay. And now that becomes an actual CAD table that I can format, different shadings and, center the point numbers or right justify them. The numeric data is all right justified as they should be. The description's left, so, um, all kinds of flexibility there with those reportings. All right. So now we've got all those points. So what do we do with those points? Well, we've got what are called point groups. So let's go to the points menu and let's use our point group manager. And that's going to bring up this little editor. I've got two menus inside of it, group and points, which you can do these various commands. There's create, new group, edit, delete, etc. Or you can choose the buttons down at the bottom. So I'm going to say create, and I'm going to make a group up here. Instead of called new group, I'm going to call this prop cores, property corners, okay? And I'm going to make these into points along property lines. You don't have to put anything in there. It just tells you what it is. And so I'm going to uncheck this include all because that's everything. But I'm going to check that I want to find it by description. And I can either set by selection from the screen, or if I set from a list, let me set from the list. Here's my list of points. So how can I use that? So I know that our boundary points are bound to be there in there. So there's a BDY. And if you wanted also BDY rad point, say I control clicked, I don't want the radius points though. I'm just going to get the BDYs. And then I remember there was another one called P-core. I think I scroll down, there's edge of pavement, there's P-core. And it may also have some. Okay, that's the end of that. So I'll just say P-core. I'm going to control click. So now I have those two descriptions are set. I'll say okay. And now I've got this group name called prop cores that include down here a description of BDY, comma, PCOR. And I'll save those. There's now that group. And it just includes those points. Let's create another one. Let's call this group building points. And let's uncheck this include all. And let's say that we want to choose. There's a building. And we'll say okay. So now I've got property corners and building points. Okay. Now those descriptions, if I edit this, these descriptions down here, you can put in things like, asterisks, meaning anything else, like it could start with BLDG. So in fact, let's go back to this property corners. I'll just double click to edit it. And if I said BDY asterisk, that means anything that starts with a BDY and then anything after it. So that picks up BDY rad point as well as BDY. So I'm going to take that little wild card out of there. Now there's all kinds of other ways to do this. You can, let's save that. Let's make another one. We'll just call this one roadway points. And you can leave include all checked on and then go to the exclude, and you can say, all right, I'm going to exclude BDYs, BLDs, and see, there's my EOPs. Those are the ones I want. And say P Core. All right. And I want to make sure I put my asterisk back here to have gotten that BDY. And again, you can just type all that stuff if you want. So now I've got from my include, I'm including all, but I'm excluding these other things. I'll save my list, and now there's my roadway points. And you see I've got all of my edge of pavement points as well as some radius points. Those are the center points of arcs as part of these points. All right, let's say okay. So now what good does that do us? Well, here's how it works. All of the commands that work for points that ask for points, if I go to points and list my points, I can either list all, which you remember was, oops, let me uncheck this report formatter and choose all. There's all my points in order. This file's small enough not to have it a huge problem. But you can type a range, or you can description match, or I now have this button called point group, and you can either, pick it from a list. So select a point. That's actually the way we made the point group. But if I click the point group button, I can now say, let's just look at my property corner points. I'll say, okay, hit okay. And now all I see in this list, so number of points listed, 36 out of my however many I had. Okay. Same thing. If I want to draw locate points, let's draw locate points. Let's change this to property corners, or to looks like property corners. And let's draw, notice instead of a range or all, there's also draw point groups. Let's draw the property corners. And so there now are my property corners. Now, here's something else for you newbies to CAD. That's supposed to have been a circle, right? But it looks like a square. That's an AutoCAD type of thing that has to do with arc resolutions and what they call this display list level of, what do they call it? LOD, level of display accuracy. So you can fix that by just typing REA to regen all, and it regenerates everything, but it's done by a particular variable called view res. So if you run this command, you say, yes, I want fast zooms. What's my curve display quality? It ranges from 1 to 20,000. They did this in the early days when video memory was vastly expensive and people didn't have much of it, and it would save on the amount of time it spent trying to calculate. There's no real reason not to have it at maximum nowadays. So I'm going to set it at 20,000. So now when I zoom in and out at great levels, they'll stay looking like circles mostly. Okay. So now there's all my property corners. I could then proceed to start drawing things, in between. And actually, if I redid that, let's try that again. Draw, locate points. Let's put these on a layer called corners. Let's draw the group. And now my duplicates is said to erase and redraw. So I'm going to draw a group of property corners. They're now there on that particular layer. If I select that, you see it's on a layer called corners. I'll now repeat my draw locate. And instead of corners, I'm going to put this one on, I think actually I have a road layer already built. Let's see here. Road edges, sure. Road edges, and I'll change the symbol to just be that little tick. And we'll draw that group, and these are my roadway points. Okay, so they are there. And if I freeze and thaw those individual layers, I go to my view, I'll just freeze by pick. So if I want to turn off all my boundaries, I'm going to pick that symbol. My road points are left. So you can see my road goes through here and there's an intersecting road. Way out here is one of the radius points. Okay. If I restore or thaw that layer back, there it comes back. Okay. So that's how groups can be helpful. Again, with our particular example, it's not very what you call it, it's not very hard to keep all those things straight in your head. They just happen to be a small enough file. But if you've got thousands and thousands of points, it's a real useful means of keeping it organized. Now, again, another useful feature of that is if we were going to, send our crews out to stake all those building locations, I go to my survey menu or Kogo menu and let's do a, radial stakeout. Or actually, I think we're going to look at my cut sheet. Yeah, I don't really have elevation information to worry about there. So let's just say we did a radial stakeout. And we did a occupied point. I'm just going to arbitrarily choose 1 to 2. And then the range of points to compute. Select them from the screen. I was hoping this would let me choose the group. I guess not. But I could certainly do a list and give that list to my survey chief and say, go out there and stake these points out. Or even if I run my utilities, if I exported, I want to export points from this file into, let's call this one point groups dash stakeout. Yeah, we'll create it. And right there we go. So group. So I'm going to take all my building points. All right. And I'll add 100. Let's add 1,000 to the point names and say, okay. And now if I list points, again, I'm still in my file. But if I change the file to that stakeout file and now list those points and just list them all, it has only the building points and they've added 1,000 to the point numbers. Okay. Looks like one of them didn't get the elevation set. So that would then be the one that I might, send out with my crews to have them go out there and stake the houses. All right. And another little trick that you can use for points or with points. I'm going to just erase everything out of this drawing. And I'm going to externally reference another file. So I'm going to either, I think you can draw xref, maybe view. You can type the command. Let's see. I don't know where Carlson has put the command. So I'm going to go up here and choose my help, my command search. If I type xref, that is going to be on the file toolbar or in the ribbon with the AutoCAD version. So the file toolbar, I don't know. It's under the file menu. So let's just look under the file menu. And there's XREF. So I don't want to import. I'm just going to go to the XREF manager. I'm going to now attach. And the file I'm going to attach is, I need to go to my current directory. If I've, huh, it doesn't keep track of that. It only keeps track of where that command has been. So I need to navigate to it. So I'm going to go down here and find Carlson projects, our class data set, and I'm going to reference in this civil demo. And I'm going to uncheck any of these. I'll make sure it comes in. I'll use it as an overlay. I'll say, okay, and boom, there it goes. And there it is. There's my drawing. It's XREF. Now it happens to be faded down because there's a setting in your CAD system, but it's there to let you know it's an externally referenced file. Now here's what, and of course, if you were to, if you were to plot it, it would be at full strength, not fade control. In fact, if I look at ref, okay. There's a variable that controls that. Let's see, fade. X fade control. Is that right? X fade. Specifies the fade percentage. Specifies 0 to turn it off. Okay. So if I run X fade control, make it 0. And if I regenerate my drawing, I unload and reload. X fade control is 0. Oh, not implemented. Well, anyway, if you wanted to see that full strength, you could do that. Now, what we're going to use is a little trick with the property corners uh, group. If you wanted to not, let's say you wanted to draw property corners at all the little uh, properties, you would have to go to something like draw symbols, insert symbols, select, a circle, say, okay, make sure your endpoint snapping is on and find your endpoint, snap, 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 work your way all around the whole thing. Okay. So a bit impractical to do it that way, but if I go to draw locate or points and I see draw locate points, and I'm going to set my symbol to be not only points, but I'm going to use this points with wipeout, and I'm going to use that circle. Now it's going to have a thing inside that's going to block what's underneath it to make it look like you've trimmed the lines. Okay. And I'm going to put this on a layer called prop corners. And I'm going to draw the point group. And the point, oops, sorry, before I do that. 5-corner circle. I'm going to turn off my description, my elevations, and my point numbers. And now I'm going to draw the point group, which is property corners. Okay. And now I've got not only that, now you can see that little hexagonal looking thing, that's the wipeout. So I'm going to type wipeout frame and make it 0 and then regenerate. So now you don't see the edges of the wipeout. So they are there, even though this line goes all the way up to the center of the point. I didn't have to trim the lines back to the edges of the symbol. So I now have, my property corners set, with the exception, I don't have ones there, and I don't think the points were created for that. There's also all those building points are just those building points around that define the edges of the building. Can you guys see that drawing very well? I'm not X fade control. Let's say 100.
The number that came up after X fade control in mine was 70, and it looks bright on my screen.
Yeah. I'm not getting mine I'm not getting it to change is the problem. This might be, see, I want to turn it off. So if I do that, whoops, X fade control, I'm going to turn it completely off. See, and I regenerate and it's not regenerating, but let's see if I force it to do this. All right, how about this? Detach. Maybe if I do it as an attachment. No, it's still going to do that. Yeah, that may be, and now because I attached it after the points were drawn, the lines are showing up. So how do I fix that? I can select it. I'm going to right click and choose draw order and send it to the back. And now my points will go back blocking out those lines. This may be a function of the fact that I'm sharing the screen through Zoom and it's not coming back because that command normally works for me. But anyway, you get an idea of some of the things you can do with points, with point groups. And like I would normally, when I draw my points, I use these, but otherwise, when I did it that time, I just did this and I don't have to freeze the layer. You can draw it all and then freeze those point numbers, description, elevation layers, but you don't have to. Double click the point and it's still there. The same point number, the same description, the whole works. Okay, so it's still a point. Now, there are a lot of surveyors, Joe, I don't know your particular philosophy at your company, but there are those surveyors that refuse to give out a drawing as a deliverable that includes points. So they'll very meticulously go through and draw circles at the ends of all those corners, and that's fine. That's something you can do. Just depends on, what you want, but otherwise they're there, and I don't know why people don't share the information because it's all working toward the same owner of the project. So you want to try to make things as efficient and streamlined as possible. But anyway, that should show you an example of how to do that. Okay. Now, with that, let's go ahead and take our mid-morning break. We'll come back. We'll come back at 11:05. So 5 minutes after the hour will give us our 15-minute break. And then we'll start into the rest of this work. We're going to talk hard about surface modeling, terrain modeling. And then we're going to go through a little example that's going to show us a lot of the commands, but it's also going to be very workflow based. So it could be the way things are based. Oh, by the way, I was telling you about that point 13 that had that description. So let me do this. I just want to demonstrate this real quick. Let's go back to draw, or sorry, set my coordinate file back to this exercise 1. And let's draw locate points. Go back to those. PMTS, draw all. Sorry, let's try that one more time. I didn't get these checked back on. All right, there we go. So remember that point 13 that I had, and it had a different description out here, and I told you field to finish brings that up. So if I look under my points menu, point and defaults, when I draw locate points, I can tell it right here to use field to finish to draw point styles. And I have to tell it a code table for those. Here's this test.fld. So let's just make up one here called there's that test. And our code is test. So I'm going to make a new code called test. And in it, when it reads the word test, we'll call it test point in my drawing. And I'll say, okay. Save, exit. So now when I draw locate my points, and I've got a couple of them that have test, there's a test 2. If I turn that on in my point defaults to use field to finish for point styles, and I say okay, then when I draw locate points and draw them all, you should see something different. So you see these now? Test point in my drawing is because, and notice it's got a different symbol, is because in my field to finish code table, I said anything with tests, in this case with numeric suffixes also qualifies. I want you to put this description in the drawing, but keep this description in the data file. Okay. So that's how you do things like setting like a 10-inch diameter oak tree instead of a 1008K. All right. So that's another topic, another training class for field to finish in the survey group. All right. So that I think concludes about all we needed to talk about with that. And we're going to talk about our surface modeling when we come back. So now we're bumped up to, we're going to come back at 10 minutes after. So that'll give us our 5-minute or 15-minute break. Okay. So with that being said, I'm going to stop my screen share and I'll pause the recording. All right. So everybody back okay? Joe, Scott, Sarah. There's Joe. Okay, Scott and Sarah, will give you a minute or two. Once you're back. Okay, Scott and Sarah, just let me know when you guys are back. Give them a minute or two more here, Joe. Okay, Scott, Sarah, let me know when you're back. Make sure you can hear me okay.
We are here.
Okie doke. So pressing onward. So we're going to talk about really the thrust of everything that we do is going to be built around this idea of terrain modeling of building surfaces. Um, Now, does anybody, like Joe, you've probably got some experience using that with Land Desktop, and the same type of thing is going to hold out. Uh, Scott and Sarah, I presume they're both new ideas for you. So,
Yes.
okay, so we're going to start covering some basics, and I'm going to let you guys read. If you look in your manuals on page 18, it starts this idea about modeling terrains. And it goes through 19, 20, 21, 22, 23, 24, and 25 down to where the exercise starts. So it's not that many pages, but we're not going to sit there and just read the pages over the class time. I'll let you study that a little more in depth on your own, but here's the basic premise. When you're going to build a continuous surface, you have to identify enough points on that surface that defines the surface. So when you think about all these points that we've been having, we bring back a point, we drop it in our drawing, we know the elevation of the ground at that particular point, but we don't know what happens in the space between that point and the next point. We might know inherently that, say, I'm picking up the edge of the pavement and I go to the next edge of the pavement point, and at that location, we're going to say, okay, the ground changes between this point and this point in a straight line. And we go get to the next point and the next point. So we do all that as well. So when we model our surface, what the computer is doing is it's gathering up all of the point information it can find with non-zero elevations, and it is um, reading all those points, and it sits on each point and it looks all around itself 360 degrees, and it tries to find another available point. It looks for things where there's nothing in between where you're standing and where you're looking. And if there's no barrier there in front of you between the 2 points, then it makes the assumption, just like you did on the edge of pavement, that the ground changes in a straight line from this point to that point. Okay. So that's going to introduce this idea of something standing in the way, what we call break lines. And here's why they're important and how they work. Because a lot of times we'll just go out there and survey a bunch of points. And if you think about it, this is the way drone LiDAR mapping works. LiDAR mapping, they go out and just spray the ground with laser scanners or whatever, and they get just millions and millions of little points, and they take them all together. And as a general rule, when they get all those points that are that close together, then everything works okay because of proximity. But here's what's actually going on. When it looks at a point, let's say the computer goes around, it's sitting on a point, it looks around and it tries to find actually two other points, or it finds any other available points, and it connects a line in memory between those 2 points. But every 3 points that it can connect lines between will form a triangle, and or 3 points is the minimum information you need to define a plane in space. You need 3 different X, Y, and the Z can all be the same, but the X and Y coordinates all have to be different for those 3 points. And then if they have differing elevation values, that just tilts that triangle in a particular fashion. Well, when that happens in the computer, all the triangle edges that abut that same triangle you're working on, they share a common edge. So those edges of those triangles are all stitched together. And so now they are considered a continuous terrain or continuous surface. So if you look at a little snippet here in your book, you can see this idea of these 2 triangles. They're together. So we not only know the elevations of the corners, but we can calculate the elevation, say here in the middle of any one of these triangles or any position in it, because we just interpolate where that happens to lie on that little triangular facet of that surface. So we can calculate from the edges what the elevation is between there. And that's how we get a continuous surface that has elevation information in between the points. Okay, we stitch these triangles together. Now, if you consider these 4 points and the way the computer put these points together into triangles, here's what got created. There's a point here at 110. Without any lines drawn here yet, it looks around itself and it sees 3 other points. Well, it sees this point and it goes, I'm going to draw a line up there and assume that's connected. Then it sees this other point. I'm going to draw a line up there and assume that's connected. And then it keeps looking around and it sees this point. I see that point and I'm going to draw a line and keep that connected. And it does so all the way around itself. So when it's done that now, it moves on to the next point. So it gets up here to this point. Well, there's already a line here and it's looking around itself and it can see over here to this point and so it goes, okay, so I'm going to make that line and assume that that's connected. And now it keeps looking around itself. And even though this point's over here, there's a line that's already been connected in between. So it can't, quote, see this other point over here. It can only see this point and this point. So it completes that triangle, moves up to this point. It looks around itself and it sees this point. Okay, so I'll draw a line there. It already has a line here to this point, and it looks over to this point, and it already has a line there to that point. So now I've successfully formed those 2 triangles. And what happens in the model is that these 2 triangles are at 110 elevation here, goes straight across to 110 elevation, and then it falls down to 100 in the southeast corner, and it falls down to 100 in the northwest corner. So this would represent like a ridge line that falls down to the northwest and it falls down to the southeast. Now consider that same set of 4 points. We'll go to the next page now, right up here, and this could just as easily have happened. Instead of 110 being able to see 110, it might have started down here at the 100 point and it connected those. And so now what's formed is this little valley floor at elevation 100, and it rises up to 110 in the northeast direction, and it rises up to 110 in the southwest direction. So this is actually a sort of inverted little condition compared to the other possibility where we had this line connected instead of this one. But if this one gets there first and connects this line, then this can't go across and see it. All right, so mathematically, both of those conditions are absolutely correct. They don't, there's nothing wrong with those conditions. What we have to do, though, is when we're gathering our points and looking at what defines our surface, is we have to know whether that's a ridge line or whether it's a valley line. So we have to go in, and before we actually model the software, the terrain, we have to pre-draw all of the edges that are out there. Those are called break lines, because this line right here is going to break the triangulation from this point over to this point. So it's going to break across there. And here's what the idea about break lines is. And it took me a long time when I was back in school learning about break lines, and it told us they were represented lines along a break in grade. And they actually are valley floor, ridge line, that kind of stuff, tops and toes of slopes. But here's really the simplicity of it all. If it's an edge on the ground, then we need to make it an edge in the data set. So we have to pre-draw those edges, the tops of banks, the bottoms of banks, the face of curbs, the backs of curbs, the tops of curbs, edges of pavement, anything that forms an edge out there on the ground, we need to draw that edge into our drawing. And there's a lot of ways that automatically do that, what we call feature extraction. And field to finish helps us do that with a lot of um, routines with that, okay? So we can't just go out there and start spraying in points. In fact, we don't need to. A lot of surveyors will do this. They'll go on a curb structure. They get the edge of pavement, face of curb, top of curb, back of curb, and they get them all four there together. And then they'll go over somewhere else and they'll do the same four in hopes that those triangles will form correctly in those regions. And they generally will, but they often don't. And they'll do something like this up here, the same sets of points. If you look at this condition, if we haven't drawn these lines in before we model it, point A can see point B, and that's correct. Point A can see point C, and that's also correct. But point A looks over here and it sees point E. Well, that's not correct. The ground doesn't change along that straight line. It has to come down to this face of curb first and then come up to here. And I didn't find a point down here first. There's nothing there. So what you do to fix that is you draw all these lines together. You draw a line through points A and B all the way for the entire length of the feature. The same thing between points C and D all the way for the full length of the feature. E and F all the way for the full length, and then G and H all the way for that full length. And then when you model it, it forces these triangles to lie in these particular planes. So A can see B and C, and that's all correct. B can see C and D, that's all correct. So those edges are done, but A can no longer see point E because that line got drawn in between there first. So it won't connect up there, but it can look down here and find another point along that line in the face of the curb. Same thing with E. E can't see A, but it can see point C and point G, and those edges are correct. It can also see point F. So it forms those two triangles, one up here. Triangle EGF lies in the top of the curb. Triangle EFC lies along the face of the curb. Same thing, GFH along the top, FCD along the face, BCD along the gutter, ACB along the gutter, etc., etc. And that's how you control that, is you have to use those break lines. And it's basically putting in the edges so that points on one side of the edge can't look across and connect to a point on the other side of the edge. That's the nut of what we're doing when we model it. Now, the rest of this discussion talks about all kinds of other data sources. Here's a list, for instance, of XYZ DEM data from a US quad sheet. And it's just a bunch of points with X, Y, and Z elevation. There's no real break lines in it. It sort of generally models. But the thing that we have to do is we have to constantly evaluate this stuff to make sure it's correct. And here's an example of a data set that was pulled from aerial photogrammetry. All of these little lines are along break line features. That might be the top of a bank, and this edge over here is along the edge of the pavement of this driveway. And then these little lines might be little drainage gullies or something. And then the points in between are just sort of random. But if you consider these 4 points here, this point can connect to this point. It can connect over here to this end point, but it can't look across this line and connect to here because the ground actually might be lower or higher along this feature here. So they've done all that, and they've done it all. You can see the extent of the data over here in this other picture. That it's pretty extensive. They've drawn all this in. Now you can't sit around and do all that on the computer manually. That's why that photogrammetry process is helpful, because they can do all that very, very quickly. But in some cases, and again, here's another idea of evaluating here, and again, using our eyes to help do that. Because we might look at this stuff in plan view and it all looks like, okay, there's an edge, and that's going to keep these points from looking across. Here's an edge and looking across, but we don't know necessarily that those edges are at their right elevations. In which case, if we're looking up here at this road edge and this road edge, if those are down at 0 and they're not given their right elevation, then points over here on this side of the road can look straight across and put points over here and make triangles, and it might go across, through the air up here, and it needs to hit that feature first. Okay. So here's an example is we have to look at it in 3D, and all of those edges now, there's the roads and the center of the stream, and they've all been placed at their right elevation. So I know that these road edges are going to keep points from over here on this side from looking across and seeing points on this side because this is in the way. Same thing along these. That particular thing there was a valley line. But sometimes, and again, like I said, if you're looking at it in plan view, it looks all okay. But if we spin it up and look at it, sometimes you'll see data like this, where road edges and stream center lines are drawn down at 0, and they're not drawn at their right elevations. So in this particular case, even though it might look like this and look okay, it doesn't look like this. And therefore, up there where that particular feature is, which is right in here, those points on this side can look straight across, and it would, just be a real mess. It would not represent what that ground looks like. So that's what we're after, is being able to put in those barriers. And here's some other potential issues that you get into when you model data. If you don't have an edge, if you can see the differentiation here, and this is on page 24 of your training guide. If you look at, see, all the triangles that got formed are pink. The black lines are all the edges and points that they surveyed. So if you don't put a line between, say, this point up here and this point down here and this point and this point, and sort of connect all those up, then what happens is you get these triangles in these interior concave type areas of the data, because when you're sitting down here at this point, it's free to look across and find any other point. It finds this one that's correct. It finds this one that's correct. It can't look over here and find this other one because something else is in the way, but it can sit here and look all the way across up here and find that point and find the next point and the next point down. And so it starts to form all of these invalid triangles. We don't really know what the ground looks like in there. And the model, though, says, hey, it's a nice, even flat triangle between here to here. and we don't know that. Okay, so that's another type of a break line that we're going to talk about called a boundary, where we have to put a boundary around our data. Okay, and here's a way that you do that, and it's called, we're going to do it with this command that calls shrink wrap entities. And it's going to outline that data to give it a boundary, and then we're going to tell it, hey, use that boundary, so don't go outside that boundary when you're modeling this software. Okay, and that's what we call an inclusion polyline. Now, likewise, there are things, if you look, say, over here at this page, for an example, there are also things like these building footprints, and those are areas where we don't really know what the ground is underneath there. It could also be the outline edges of a pond. We don't know what's going on underneath the water's edge. So what we have to do is identify those closed polylines as exclusion polylines. The border, the boundary that's going to form around this edge and all the way around the data, that's going to be our inclusion. And these holes that we don't know anything about are going to be our exclusion. And what it does is it builds these triangles, and then it just cuts those triangles out of those exclusion areas. And it doesn't even form the ones in the inset part. Okay. So right up here, and again, one of those little take note icons is you're going to use your eyes, think about it, use the tools that, so what you give is going to be correct. Okay. So we're going to look at some idea about these break lines and how they have an effect, and we're going to learn how to start to build these surfaces. So let's open up a file in our data set called sample from T3 Global. And that happens to be an actual file from, let's see, 50903, yeah. That's a file that was actually delivered for a project by an aerial mapping company called T3 Global Strategies. It's here south of Pittsburgh in Bridgeville. Joe, you'll know this site. I'm going to zoom out a little bit here to show it to you. I'm going to make sure in my settings, my drawing setup, make sure I'm at let's go maybe to a 40 scale drawing. I'm going to set my LT scale back to 1. And I'm sitting on Alabama, so I'm going to define my projection as being PA South. And I'll say, okay, I'll give it a quick save. Now, because I've given it a known projection series, I'm going to switch over to this. I have the GIS module. If you have that, you can do that. And then on the images menu, you can place a Google Earth image. And this is a good way to verify. It's not survey accurate. Okay. It's a Google Earth. It's not all that accurate. So I need to give it a file name for the image that it's going to generate. So I'll give that site location. Now onto my prompt, pick from the screen or use a map. I'll just pick from the screen. And I'm going to come down here. I'm going to go up here. And now I've got available from Google Earth, low, medium, and high resolutions. I'll take it as an aerial map, or it can extract out a road map or a hybrid. Well, let's do a hybrid. We'll get the labels. And we'll say, okay. So it's going to go out and hit Google Earth. And it's going to download the data, and it's going to build an image and place it under all of our stuff. And here it happens to be. And I'm going to tone this down a little bit here so you can see the line work over top of it. And Now where this is, I thought I told it to get hybrid to give me road names. Oh, there it is. There's 1013 North Breezewood Road. This is US 30. This is, let me freeze off these brake lines for a minute. This road is, there's I-70 coming down. That's the on-ramp to I-70. So this is that truck stop down at Breezewood, okay? Up here's the big truck stop, and you come off the turnpike, you come down here, and then there's the ramp that heads you back up to the turnpike. And this comes you down to those stoplights where you then get on I-70 to continue on your way to Washington. Okay, so that's where the site is. Its actual site, it was an actual project delivered for the, delivered to PennDOT, I believe. So I'm going to now, I'll freeze that layer, and now we're back to this. So let me turn back on all my layers. In fact, I don't need this thing anymore. I'm just going to kill it to get it out of there. All right, so you should have your file looking like this, and it looks like a real mess. But here's the way that they did their triangulation. I'm going to set my points style here for a minute. I'm going to set my point object style to be, I'll choose these little X's instead of these dots. And let's make them a little bit bigger so you can see them all. Yeah, let's do that one more time. Let's maybe make them a full 1 foot tall. So there's now, you see those little X's? So what they did when they compiled all this data in the photogrammetry process, they've got the machine set to go every so often, every 10 meters or so, and plop a point down on the ground. And they also find, hey, this looks like the edge of a pavement. So I'm going to plop a point and I'm going to connect all those edges. Here's the crown line. Here's the edges of a sidewalk, or a curb. So they've actually gone on and done all that stuff visually in the photogrammetry process. They got a bunch of points random on the ground. They've got all these little break lines, and they used that to generate these contours that you see. Let me set something up here. It's LT scale on back to 1 regen. Oh, there we go. So now I got my line type showing up. So I've got some dash contours in this area called obscured. Same thing over here, there's dashed, and it's in this area that they designate as being an obscured area. They can't really see it. You can see the word there, obscured. So that's what they've done, is they've gathered all that data and they've turned it into a surface which produced the contours. So these contours are actually the output of the process of reading the data. So to show you what the data actually really looks like, I'm going to freeze off these contour layers so you can see what they started with. And we're going to do that on the view menu, and we're going to choose freeze layer by pick. So I'm going to do that. I'm going to come down here and pick that contour line. I'll pick the label as well. I'll pick that intermediate contour, and you see it's freezing the whole layer. I'll freeze in these obscured areas. So now all the contours are gone. Things like this tree line, they're down at 0, so they were not used in the compilation. And in fact, let's see what they did use in the compilation. How are we going to do that? We're going to look at this in 3D. So let's take a look at the data. And we have two options. We'll go to the view menu. We've got a 3D view, and we can use the drawing viewer, and that's going to look at the data in the drawing. And we have a surface file viewer that's going to ask you to give it a name of a surface file that you saved and load it up in the viewer. It's actually the same viewer. It's just what you start with is different. So let's choose the drawing viewer. You see that icon is a cube. The other one's a little like a stockpile on the screen. And those icons are also up here on this toolbar. So I'm going to use my drawing viewer. It asked me to select entities for the scene. So I'm just going to drag my mouse around it, hit enter. And it's going to go into the viewer. Now remember, I've got this ignore zero switch on. If I turn that off, then you can see, you know, all that stuff underneath. But if I turn that back on, it's only what's here in the view. And there's my data. Now, here is how you control what you're looking at in this viewer. And it's real easy. First of all, you want to always make sure over here, and I'm on the view control tab at the top, always on the right, you want to always lock that Y axis. Okay, you can unlock it, in which case, you know, you can move it around all kinds of ways. But if you lock that axis, it's going to help you to be able to set your view. Now, these different icons will do different things. You can see your color by elevation, remember. We looked at it a little bit yesterday. And this business up in here, this sets the light source and the way shadows fall, and it doesn't have any effect when you're not looking at 3D faces like on a surface file view. But there's brightness and contrast controls. There's zoom in, zoom out, zoom dynamic, all these kind of things. That actually, just use the wheel on your mouse like you do in the CAD file. It works just fine. Here's a pan button, same thing. Just press and hold the wheel on the mouse and you don't need to use it. The icon you're after is this one right here. That's the one that you're going to use most often. These down here will shade in the faces and unshade them. This lets you pick things in the drawing. This sets you back to plan view. This sets you to plan view and zoom extents. So this icon that looks like that 3-color cube and a little rotation arrow around the base, that's the icon we want. So we choose that, and that now loads our cursor. And if you see the cursor on the screen, out here on the edges, it says Z, and it shows a rotation around the Z axis. But as I approach the data, and it's not exact, it doesn't actually recognize the edges, it just gets close. And so at some point, it will switch, like right there, to an XY. So when you're over the bulk of the data, it says XY, and when you're outside, it switches to Z. So here's how you control that. If you think of this as you standing in your driveway and you're looking at the data, and that's your garage door, right? Now, what you want to do is you want to raise up your garage door. Now, this is not one of those articulated ones. This is just a slab. You grab it at the bottom, you lift it up, and the whole thing goes up as a unit and rolls into the top of the garage ceiling. So what you want to do is put the mouse down toward the bottom, make sure it still says XY, and click and hold the left mouse button and push up. See, if you go left and right, it won't move because we've locked that Y axis. So we're going to push up only. And if we have to get another bite of it, let up the mouse, go back down to the bottom. And you want to lay it up so it's, you don't want to go, you know, too far. You want to lay it up to it's mostly sort of oblique, you know, mostly flat, but not all the way flat. Then let the mouse up and now come down to the bottom where it turns into a Z, and now you can press and hold the left mouse button and spin it around. So I'm going to go back to plan view, and I'm going to show you, let's say I wanted to look at this little curve down here. I want to position my eye up here and look down that curve and see what that looks like. So I'm going to do it the same way. I'm going to click here and I'm going to push up and get it sort of laid back like this. And then I'm going to go down the bottom and I'll spin it around and get lined up and maybe reposition a little bit like that. And then I'm just going to point at it and use the wheel on the mouse to zoom in. So that's how you can control that. If you wanted to look at, say, the valley with that little pond that was been set over there, I'm just going to, again, turn this around, zoom this up, and then zoom into it. There's those edges. Okay. So this is the data that they used to create the contours. Now, while we're in the viewer, I'm going to go over to the model tab. I've got some buttons. I can add a surface. I haven't made one yet. The next button means to add entity. So if I click that, I can go out and find in my drawing some entities that I want to add. And I can pick, just a few, let's say I get these 4 entities here. I finish and I come back, I hit enter and it comes back. And well, actually, that's not what I wanted to pick. I wanted to come back out here and, oops, I want to add entities. And from here, I need to turn on my layers. So now if I want to pick, if I just grab everything again, it's going to grab the contours that I turned back on. And now you can see the contours. And again, those are the ones that they created from that data. And in fact, from here, you see these different layers are on. And if I open up that layers list, I'm going to come down here where it says VTopo or VTopo DTMO. That's or here's break lines. So if I double click that, turn it off, the break lines go away. I'm going to double click the points layer, which is this DTMP. And now these are the resulting contours that their process generated. It looks pretty nice, right? So that is all the stuff that we're going to be using back and forth to evaluate this stuff, right and left, and turn layers on and off. You can actually change the layer colors over here in your layer definitions. You can right click. Let's see, what do we have? We have the major contours. If I right click and set properties, let's make them show up red. So now I can see all those very quickly. Now that doesn't change them in the drawing. It's just for the viewer where I've done that. Okay. Another control you have, let's say you have a very flat site. In fact, my view was a little bit exaggerated. There it is now. Because that vertical scale stays from the last time you run it. So if you pulled this down, say maybe had it set to 5, well, you can see that's a 5-time vertical exaggeration. So if you're in a real flat area, that might help you see some subtle changes in the ground. All right, so I'll put that back to 1. That's what it really looks like. And that's where it goes. Now, the reason I wanted to point that out with the contours is this is a very common mistake that people make. And we're going to learn about using break lines because of this. When we see a contour map, so let's go back out to our drawing. Let's turn on, let's view, and choose thaw/on all layers. So now they're all on. And I want to isolate just the contours. So I'm going to go back to view. I'm going to choose isolate layers right here. I'm going to scroll over here into my drawing and I'm going to pick the major contour line, the minor contour line. I'll do the same thing for these obscured areas here and here. And now those are the only 2 layers they've been isolated. And if I were to go back here and view this again, I'll just select this. I'll choose my little cube icon from the toolbar. Then there's what we were looking at. We say, oh, hey, great. I've got this contour map. Let me build a terrain model from these contours. And you can certainly do that. And sometimes that's all the data you have, and that's what you have to do. But here's what happens. When you go to model this terrain, if you look at all the points along this feature, it's going to sit at this point, and then it's going to look across, for this point to these points over here. So it sits here at this point, and it looks across, and it sees that point, and it goes, okay, the ground changes from this contour to that contour pretty straight. All right, so I'm going to make a straight line there. Straight line to all of these other different points. But what happens is, as it gets closer into these nose-shaped little valley features, it sits on this contour, it looks across, that's okay. And it might sit here and look across, and that's okay. But it gets up here, and maybe, instead of seeing this point, it looks over and sees a point along this line, and it starts making triangles in here. And those triangles are all the same elevation. That's what we call flat triangles. And so what happens, here's a better example down here, is, this point can look over here and see this point. So it says, okay, that's going to be my triangulation. Same thing here, there. But really, if I go from this point to this point, in truth, let's call this elevation 101 and this elevation 100. If I say from 101, oh, we're across here to 101, then halfway in between, it's still at 101. But really what it is from 100 back here all the way up to 101 back here. And so this should be like 101.5 or something in between here. So if I don't have that line in between there, I'm going to get these flat triangles, and it's going to give me an error in my model. Okay, we're going to take a look at that and what they look like and how to tell something, because a lot of people, when they get a map like this and they say, oh, I'm going to build my existing surface, and they'll haul off and they'll do it, and they get no errors back because it models it correctly. And the problem is it's wrong, and they have to evaluate that and see. So let's go through that process with just what we see on the screen right now. Let's go to the surface menu, and let's choose triangulate and contour. Now this is a combination command. It's going to do the triangulation, and it's going to also potentially draw contours, but I'm going to uncheck this draw contours bit right now. I'm just going to build the surface and look at it. When draw contours is not checked, labels is not available. And I also have a selection where I can filter what it is that I select as my data set. In fact, you can even not have any data, and you can choose if you want to specify your options. You can come down here and just read a file. Okay, and it can bring you all that out there. But we want to make sure those are unchecked. Now, you can always draw the contours once you've saved the surface file. That can be done at any time. In fact, we do it multiple times sometimes to help create a map. So the first thing we want to do is make sure at the top that we are going to write the triangulation file. So check that on and hit the select button, and making sure we're in our right folder, which we are. We're going to give it a file name, and we're going to call this name EG for existing ground, and we're going to call it CTRS only, contours only, okay? And we'll say save. So that's going to be the file that it creates. Now, we're not going to draw any of these other features here. Again, you could draw those later if you wanted. And we're not going to have any inclusion, exclusion areas. We haven't drawn anything yet. And here's that shrink wrap perimeter. Now, it becomes part of this command. It used to be separate. You had to draw that feature first. Now you no longer have to, but I'm going to pull this down and choose none for the perimeter reduction, so you can see the results of not having a boundary. I will make sure that I ignore my zero elevations, and I've got a min-max or a maximum triangle length, interior and exterior of 2,000 feet. That's another way you can help control these edge triangles on the boundary. So you can say maybe if 200 feet is all, you don't want anything more than 200 feet long, you can, or 50 feet long, whatever. That will help control that. I'll show you that results here in a minute. And so I'm going to uncheck everything else. I'm just going to have on to right. I've got my shrink rep set to none, and I've got my ignore zeros. Okay. So let's go ahead and say okay, and let's watch the prompts. It says select entities, but we read the line above and it says select the points and break lines to triangulate. Now, in this case, the contours themselves serve as break lines because points on one triangle can't look across, or one contour can't look across the other contour to these other points. It can only see points on their available free clear space. All right, so I'm going to just now I'm going to just click a window and drag it across everything and hit enter. All right, so it now comes up and it says right here on the command line, it says it right in the triangulation file, e.g. contours only.tin. So that quickly it built a surface. That's the temptation. When you go to do this, you go, oh, hey, no errors. So I'm good to go. All right, well, let's evaluate that surface. Let's take a look at it. We know what it's supposed to look like here with these nose-shaped contours along the road edge, for instance. Okay, so we're going to go to our view menu, our 3D view, and this time we're going to use a surface file viewer. So if we do that, we're going to find that one that we just made, EG-CTRS only. We say open. And so here it comes. Now I've got my contours set on. And I'm going to turn those off for right now. All right, so right now you can see this light source. You can see how you can change the shading. And I'll tell you right now that if I put it down here, this looks like it's raised. So does this. This looks like it's sunken. The road looks like it's raised. That's actually backwards. And the reason for that is that all of our conditioning as human visual people, most advertising, for instance, has drop shadows always down and to the right. So I'm going to put my light source up and to the left. So now these look depressed areas, and this is a raised hill, and the road is down in a depressed area. So that's really looking like, oh, hey, I've got a good model. That's good to go. But come over here and examine these road edges. So what should have been a nice smooth line down the face of that, or the edge of that pavement, if I were to draw a profile down that line, I'm going to come over here and I'm going to hit this flat spot and then drop. Then I'm hit a flat spot and drop, flat spot and drop. So it's going to look like a stair step, right? So I know that those contours are not correct. If I go to my settings tab now and turn on display contours, and you can set the interval, let's just leave it at 1, you can see the results. The original contours are supposed to go all the way up to here and back, but you see how it flattened them out. This one worked, but that one didn't, that one didn't, that one didn't. Okay, so you've got some problems. I also see that it's considered this back edge back there as being, sort of like a wall because it made all those long, skinny triangles. Go back here. Let's see, let's turn those off and turn the triangle edges on. And let's go back to zoom extents and let's maybe turn off the fill in. All right, so you see all these long, skinny triangles out here are invalid triangles. They're not really there. Okay, but that's how they worked. All right, so I'll turn those triangles back off. And I'm going to shade in the areas. And you can superimpose them, as you want to. All right, so if when you're looking at the surface, if it looks like that, just hit that button and that colors in those little faces. All right, so we've got some problems with this. I also notice up here, you see this little feature? It looks like a little ski jump coming off of this down to there. But that's really, there's a loading dock right here. So it's a retaining wall. And so this ground out here doesn't actually exist. It's because the contours, I'm going to come back here. I'm going to go to my model tab and I'm going to choose add entities and I'll select these contours now. And so when they come in, you can see that it went from the contours. Let me make sure my contours are off. Yeah. So what it did is it went to the ends of these contours and it looked over here and there was nothing in the way. And so it just went zoom. There's a triangle. There's a triangle. There's a triangle. Here's a point. Go to that triangle. But there's supposed to be something in the way. And in fact, there is. There's a break line in there. A couple of other features to note. Right in here, there's supposed to be some curbs. Okay, I see nothing that looks like curbs in there. It's just a real mess. Okay, same thing in here. There's some curbs around there. There's some curbs down in here. But you can't tell that they're there. All right, so that's basically a huge mess that we made by building contours or building a surface just from the contours that we had in our map. All right, so we need to either go in here and draw in all these break lines that we know are going to be necessary, like down this ridge line here, down that valley, down the crown. They've already done that for us, so we're not going to have to do it. We need the same one drawn across here. And in fact, if you were to draw that in, and it would have to be a 3D break line. So just to show you that effect, I'm going to go to draw 3D polyline, and I'm going to put this on a layer called BRKLN. I'm going to say, okay, and I've got my endpoint snaps on. So I'm going to come up here and go endpoint to endpoint, 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 and endpoint, 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 endpoint. Anyway, so you get the idea is you could spend, quite a bit of time putting this stuff in. But of course, we're going to want to normally do that correctly. Now, to make sure that I've put those in the right location, I'm going to view 3D view, drawing viewer. I'm going to select these few contours and that line. And let's make sure that we don't see that white line actually did catch those endpoints. I didn't miss something and drop down to 0. So that's what I wanted to verify. All right. So now if I triangulate and contour, I'll go back to surface, triangulate and contour, and I'm going to leave the file the same. We've just added that one, so I want to show you that effect. Actually, no, we'll call that EG contours only -1 break line. Let's say okay, and now because we've got that one break line in there, we modeled the surface, go back to view the surface. There's the one with the one break line. And now, well, it's different. There should be another break line in there. Let me see if I can spot where it needs to go. I think if we went from here to here, yeah, that should probably have fixed that. So let's turn these edges off. And so now you see I've cut that effect out. Let me go and get my right cursor. So now I've limited that big ski jump that was down there. So I fixed that one. All right, but there's an immense amount of mess. Look at all these stair steps that come down here and evaluate that. No, I'm not going to save that change. So I'm going to come up here now and get rid of that file that was for illustration purposes. Same thing, if we were to put a break line down these edges, a 3D line, and we went from here to here to here to here to here, here, and here. And that's all we'll do for now. And now let's triangulate and contour again. And we'll this time keep the same file name. And it found me a place where I had a crossing break line. Yeah, right there's where I crossed. So what I need to do is, looks like I missed one. So I'm going to right click and add a vertex. There we go. So now I repeat the command, triangulate and contour. Say okay, yes, it's okay to overwrite, select my data. I'm just going to type all and hit enter a couple of times. I built my surface. Now compare that edge now where we put the break line in. You can see that looks much nicer than it did before with all those flat edges, correct? All right, so one other trick that we can do, again, like I said, sometimes all the information you have are just contours, and you have to do that. You have to find some way, that is around that. You would come up here and maybe add this obvious break line from, it probably went from, say, down here up to here and across, instead of coming up and back down. I think that was my problem. So I'll do that same thing right in here. I'll go from here. Whoops, I'll go from here to there. There we go. And let's see if we can find where it probably ends right there. All right, so now if we repeat that command, triangulate contour, and let's grab the data, view the surface. Now I'm back to these flats because I took that one out, but you see I've managed to eliminate that ski jump out there because of that one break line, okay? So all of those are little techniques that you're going to use to be able to modify that. Now there's one other option here. Let me put that guy back. Is if all we have are contours and we don't have enough hours in the day and days in the week to draw in all these little nose area break lines, there's a switch that can help us. So if you go back to surface, triangulate and contour, there's a section down here where it says adjustments for adjustment for source of data of contours. See that little box? So what you're looking at, because remember we were talking about those flat triangles, you want to turn on to minimize the flat triangles. And so now I'll show you this one. It was going to be EG contours only, no flats. Oops, sorry. No flats. Dot 10, and let's take this dot out here. There we go. Now we'll say, okay, we'll select our data. Go back and view our surface. And now you look over here, and that road edge is nice because it got rid of those flats. It didn't do so well on this side, okay, because there's a little sidewalk in here, and you can see right in there. And if you were to, say add a break line from here to here, that would get rid of that one. You can add a break line from, I don't know where the triangle edge is. Let me see here. My navigation control. Okay, now. So that went from there to there, and then maybe one went from, so to keep this little high point from forming, it needs a break line from there to there. Nope. There to there. Can't do that one. How about from here to here? I want to get rid of that one. So if I go from here to here, it can't do it because I put one in there. Anyway, so there are, some techniques, like I got rid of the one out in the street. But you could have put like from here across to here to get rid of that. That's what I was actually trying to do. Say from here to here. Yeah, there you see how it cleaned that up a little bit. And then you would do the same thing, say from here to here. Except I didn't catch the corner. Well, anyway. So that's a little technique to minimize flats that will help you get rid of some of those areas. We still have these triangles out here in the edges. So let's see an effect that will help us to fix that. So if we go back to triangulate and contour one more time, and this time we'll keep minimize flats on, but this maximum edge length for triangles on the interior, like if you had a pond or something in there, you could limit that. Oh, excuse me, but you don't want to make it too small. Let's say if you made these, 50 feet, or let's say 25 feet, and you made this one 25 feet, and let's change our file name now that says no flats, limit edge. And say okay, grab the data. And it gave us a little warning that it got rid of some triangles. So there's now our file, and you're going to see some holes in it. Because see, those are those interior triangles that were over 25 feet. They got chopped out. So what you would do then is, I'm going to repeat the command, triangulate and contour. I want to make sure my interior sides are up. I'll keep it back at, say, 2000. This originally was at 2000. Let's make it 200. And we'll say okay. Overwrite the file, grab the file. Skip 95 edges that exceeded that length. And so now we look at it, and we're going to be a little better. So the interior is whole. Looks like these back ones got taken out, but I still have some up in here that you can see. Those were less than that number. I got a few down here less than that number. So we could have Let's just repeat the triangulation and let's change that number down a little smaller. Like maybe make it, and if you try to make it 0, it can get rid of some on the edge to help define. So if I make it say 25, got rid of 550 triangles this time. So let's see what happened. All right, so there you see it was too many or too tight because it's still, these were edge triangles and it pulled them all the way. Once it gets rid of the one outside here, it looks at the next one and the next one and it kept going. So you would really need to try to balance that with something more like, oh, I don't know. You can keep trying it, 50, 50. And just back and forth and keep viewing and recognizing. Now it's a little better, but I still lose some stuff out here, some stuff in here. All right, so that's not a very effective way to do that unless you got a good sense of that number. Maybe, make it 100, I think might give us, we'll make it, we'll view it. And that's a little better. I still got a chop out of here and some chops up here, and I didn't quite chop enough out here. As you can see, these are invalids. But up in here are some that should have been there that are no longer there. Out here's another one. That one should have formed as well. So, you could play around with that as a number, but there's an easier way of doing this, and that is to draw the border around the data. And all it needs to be is a closed two-dimensional polyline that says use this as a border. Now you could do that. Let me set up some layers here for a minute. I'm going to change my break lines to be that color. And I'm going to make a layer called TOPO dash. I'll make that one red. And I'll give it some line weight so you can see it when it forms. And I'm going to turn on down here to show line weights. I'm now going to set my current layer to topo BDY. All right, so now you could do a couple of things. You could simply draw a 2D polyline using those current edges, and you could draw, something like this. And let's just close that. Okay. And we're going to triangulate and contour again. And this time I'm going to give it a new name. It's going to be contours only. It's got a border. Now, what I need to do in this case is come up here and say, use inclusion and exclusion areas, and I'm going to trim the areas at the boundary. I'm not going to remove them. I'm going to just trim them. And I'll say, okay. And now it says select entities, but read the line above because now it's different. Now it says select inclusion perimeter polylines, and there can be more than one. So if I'll select that polyline, that's my inclusion. I'm done selecting, so I hit enter. Now it says select exclusion polylines. I don't have any, so I'm going to say enter for none. And now it says, still says select entities, select the points and break lines to triangulate. So now I'm going to grab this and, oh, I still forgot to change that length. Let me try that again. Triangulate and contour. Let's change that back up to 2000. Yes, overwrite. select my inclusions, no exclusions. Now select the data. And now when we view it, you can see that I've now got nice squared edges. And now I've got this little edge up here. So if I still didn't get all of those in there. The reason being is look at your triangle or your boundary. It didn't come in all there. So one way to quick fix that is just convert that into an arc and say that maybe we'll move that corner up to there. And maybe move this one down to here a little bit. So now that would help do that. You could adjust this as you go along, okay? That actually should come into there a little bit better, okay? So now if you do the same, triangulate and contour. Okay, to overwrite, select my inclusions, no other inclusions, no exclusions. Select the data, built the surface, we view it. And so now, see how it's all snugged into that line and it all looks like it should look. Okay, in terms of the border. Now, what I did was I very quickly just drew that around there. Now, there's an even faster way of doing that. In fact, it can be, let's do this. I'll take that off. Let's suppose you have all this data, but you're only working in two spots in the data. Let's say you're working up here, and maybe you're working down in an area down here around this pond. And I have to make sure it's closed. All right, so now when you triangulate and contour, yes, it's okay to overwrite. Select the inclusion areas. I'm going to select both of those. I have no exclusions. Now select the data and you're going to see what happens to our surface. It is only within those included areas that we have surface data. Now that is a single surface file. And it's called a TIN file, TIN, because it stands for Triangulated Irregular Network. And that's where that term comes from. So those are ways of doing those. You can draw those yourself on there. They're just polylines. However, there's another quicker way of doing that, and it's on the draw menu, and it's called shrink wrap entities. It looks like a little birthday gift. And what we're going to do with this is we're going to put that, I'm going to put that back on my topo boundary layer. We're going to have two different types, across gaps or bounded line work only. If I say across gaps, it's going to let it go from end to end to end of all these little things it finds and sort of shoot the gap across there. So if I allow it to go across the gap, and you can limit the gap size, I'll ignore anything with zero elevations. I'm going to make it a 2D polyline instead of a 3D polyline. But for now, let's pull this perimeter reduction down and change that to none and say OK. Now it says select the things you want to shrink wrap. So I'm just going to grab my data. And there it's going to go. Now that would have the same effect when we did the stuff without an inclusion boundary and we said none and we had all those little triangles, because here's where they're going to happen. So you could take that and then you could do things like, add in these vertices, convert that to an arc, do all kinds of things to modify that, add some vertices down here. You could do that again, but if we go back to our shrink wrap entities, this time, instead of none, let's pull this down and say high. And let's say okay, and I'll explain the effects of what's going on here. So here it is with a high reduction of the perimeter. edges. And what it's doing when you say none, low, medium, or high, is you're telling it how aggressive do you want it to be to eliminate the perimeter edges. And what it's actually doing, by the way, when it shrink wraps is it triangulates all that stuff that you've selected, and it looks at those exterior triangles and it says, how aggressively do you want me to start removing exterior triangles? It does those removals and then it just wraps a boundary around everything that's left. It does all that in memory, of course. So that's a little bit too jagged, a little bit too much. It's like setting that exterior triangle length too low. Okay, so you would want to try to find a happy medium, something that works nicely for you. Okay, so if you do that command now, and let's change that, we'll go back to shrink wrap polylines, and instead of high, let's look at medium. That'll be a little less aggressive. Let's see what that looks like. A little better up in here. There's still a bunch in here that's a little too aggressive. So I'm going to undo that and I'm going to repeat my shrink wrap, and let's set that down to low and say okay and choose that and see, oh, that's better. And what I would do is I would, since I know that this is invalid, I just snug this up here like that. And I might come up here and say, get rid of this one. Or instead of doing that, hover, click, I'm going to go to my tool that's also on my polyline toolbar, and I'm going to remove a polyline vertex. I'll select this, and now I just have to click nearest the ones that I want to eliminate. So I'm going to say there's one in there, one in there. Let's maybe get rid of that one and then that one. All right, so you can sort of help, and you see you got all of these down here, and you could get rid of, say, all of these little lower points. Yeah, so a number of things that you can do with it to smooth it out if you wanted. Now keep in mind, let's see if I do that again down here. See, I've got this, that these are probably okay in there. So I'm going to let it sort of interpolate in those areas. Okay, so now what you need to do is realize that really all you're doing is you're creating a boundary outside of which you don't want any surface information. And if you're not working out in those edges, it doesn't matter. So I wouldn't waste a whole lot of time trying to, to get rid of that uh, as a little inset into your area unless you needed that stuff to be pretty exact. Okay, so keep in mind the purposes of what you're doing. Here's another idea. Remember all those flats that we were doing? We wanted to get those so that we can see those edges and be real good with them. If I'm doing this project, if I'm building a surface that says, let's look at hydrology on a county-wide basis, well, I'm not going to bother worrying about those little curves because I'm more interested in overall big flow regimes. So I may just grab it, do it, and be done with it, and not worry about those things to deal with. It's just a matter of what your purpose is. But if I'm using this as a design base, I definitely want to see those curbs and all those different kind of things that I have in there that I don't have in just the contour data. So this is one way, again, you can do that. Draw, shrink wrap, create it. And I generally do that. I generally like to do that and create it myself. But here's another, and I'll go back to triangulate and contour. there's a switch here too that instead of using inclusion exclusion areas where it made me pick it, I'm going to uncheck that. And now shrink wrap is part of what goes on in the command. And right now there's none, so I'm going to set it to low. And if you hit the setup button, I want to see it. So I'm going to draw it as a 2D. I'll draw it and I'm going to put it on that topo boundary layer just so you can see it once I get it done. I'll say okay. And now it's not asking me to select the inclusion. It says just select the stuff you want to triangulate. So I'm going to do this. And it's going to go through it and it's going to draw in the boundary that it calculated. Okay, and so again, what you might do is, I'm going to fix that little one guy there and maybe maybe I need a couple of these. Spots in there. So you can make your adjustment however you think you might need to do it. Okay, so that might look good. And then you would go back and rerun the command, triangulate and contour. And instead of letting it shrink wrap again, although if you did that, well, we told it to ignore zeros. I'm going to say this time use the inclusion areas. Go back and read my prompts. And now it's going to ask me to select the inclusion parameters, no exclusions, grab the data. Off we go. And there now is my data. Everything's looking good in terms of the edges. Okay, so that's how that boundary part works and why you want to use it. And again, if you're not working out here and you're only working in here, I wouldn't worry about those. In fact, I might even just draw an area around my site that I'm interested in and let that be the inclusion. All right, so what did they really do in terms of the data? If I go back now and go to view, and let's say thaw/on all layers, here it is back turned on with everything. And remember, the data that they use were all the white lines, the break lines, and these pink points down here. So let's isolate those two layers. I'm going to go to view, isolate layers, and I'm going to pick one of the white lines, and I'm going to pick one of those little pink dots. And now that's the only thing that's on. I'm going to verify that with my 3D data viewer, not the surface viewer. And there it is. And that represents everything that they did, everything that they used. Now, remember, these lines all have internal vertices. So those are going to be points along the triangle, along the triangles. And let's build this surface now. So I'll go back to surface, triangulate and contour. I'm going to give it a new name. I'm going to say EG, and this time instead of contours only, I'm going to say EG-BL-PTS, so break lines and points. Okay. Now let's notice the difference. So now it says select the inclusion perimeter polylines. Oh, I didn't do that. Let me escape and repeat. Triangulate and contour. I'm not going to do that. I'm going to let it do a reduction, and let's see how that works. So I'll do that. It's going to build the surface. Now I've got a couple of error conditions here in my data, and this viewer pops up. And it tells me I've got some crossing break lines. And what happens is you get a place where a break line crosses. So if I select this, and I zoom to and then zoom in, you're going to see one of their break lines actually went across the other break line. If I select that And let's make that red. Let's make this one green. So you can see the green line cuts across the red line and then back outside of it. So what happens is when it crosses, there are two different elevations at that one point, and it doesn't know which one to use. And it tells you they're different by 0.321 feet. There's another place if I zoom to this one and then zoom in, you can see that one just snips across it a little bit, and that's only by 0.08 feet. So what I would do is probably just select that and just drag this point back a little bit. It's not letting me drag. Let's see if I drag here. And let's do nearest. So that would go away. Good, that one right there is back again on this particular feature. That's a head wall. So what I would do is maybe just pull this guy back in a little bit, set that to none, and just go to the inside. It's also go to none so I don't snap, and I'll just put that there. So now those would all be eliminated. I've got some vertical edges, and that's where the points line up X and Y, but there's a little differentiation between the height, in this case 400ths. So what I would do in this case is take this and pull it back a little bit. I'm going to go to the nearest point right in there. So that's eliminated that one. I'll go to this one, and that's a vertical edge. And if you look at that particular item, see there's one here, and if I hover in that grip and look down here at my status bar, that has an elevation of 1300.81. If I select this one and hover, that's got 1300.80. So there's a difference of 0.011 between the two. So I'm going to take this guy out and just snap him to the end point of that one. So now I'm at 0.81. This one's at 0.81. So now that would eliminate all that. I'll exit that. And now all I have to do is I have to go back and rebuild it now because I've done that. I could also, you know, bring that in a little bit there and take some of these edges up here. Now, one thing to notice, this is the edges to which they compiled the data, but look what, I'm going to turn these layers back on. You see what they did when they delivered contours? They cut out 50 feet from the data and stopped their contours 50 feet out when they were doing it. And that eliminates all of that little jibber jabber stuff around there. That's just their policy, the way they do that. So I'm going to go back and isolate those layers again that we had here. Oops, I did. One too many. Let me take my boundary and thaw that one. All right, so now I would go and just repeat my triangulate and contour. And this time, since my first pass did my inclusion, I'll go ahead and select it. Yes, it's okay to overwrite. And so I will select that is my inclusion. No other inclusions. Any exclusions? None so far. And then select all my data, and I should get a clean surface. It still had a crossing break line. It shows 0 elevation, and in fact filtered out 16 errors below the tolerance settings, which is in here. And so I said, if it's within 1,000th of a foot, don't flag it as an error. That's why those were filtered, okay? So that's close enough to the same. And what's going to happen is everywhere it had the conflict, it's going to choose one. And so within a thousandth of a foot, I don't care which one it chooses. I'm just going to say exit. So now I've got a surface, and if I look at this surface now, e.g. with break lines and points, it looks similar, right, around the edges. But look at the difference. I see curbs. I see retaining walls. There's that retaining wall right up there. I've got this retaining wall as well as the curb entrance. Okay, so this is a very highly accurate surface. Notice I don't have those flats going down either side of the road. In fact, I see there's a little, it's not really a sidewalk, it's just an elevated platform there. It's the back of an edge. And it was graded flat. And so I'm picking up all of that now because I've used those break lines. And and you can see that they've even modeled, you know, the thalweg of the stream that drains this pond out of here. I've got this pond across here. It's all very nicely defined. And that would be now worthy of using as my design base because I've got all of this stuff in here. Okay. Now, real quickly, I'm going to go back and turn all my layers back on, and I'm going to now thaw, or not thaw, I'm going to freeze by pick. So I'm going to view freeze layer by pick, and I'm going to turn off those items. In fact, let me do the boundary while I'm at it. And now we've got the drawn contours, and all these other things are things drawn down at 0 elevation. They're just edges, you know, showing you where they are. But I've also got these building outlines. Okay, so let me go. So what you could have done, we won't take the time. So when you could have turned on these building layers, which is V building outline. In fact, it won't take long to do. Let's just do that. Let's isolate that, and that. So now I've got, let's turn my building layer so I can see it better. I'm going to change the building outline from white to cyan. There we go. Now those are down at 0 elevation, but they are closed polylines. So now when I triangulate and contour, back to surface, triangulate and contour, keep the file name the same, use inclusion exclusions. Then I'm going to say, all right, where's my inclusion boundary? There's one. I don't have any other inclusions, so I hit enter. Now my exclusion, I'm going to come up here and pick, and one more down here, pick, and say, actually, I don't think that's a building. I think, yeah, because we've got points in there. So I'm going to type R to remove that one. It's actually just a slab. And now I'm going to type A to add, and I'm going to pick that one that I missed. Okay, now I'm done selecting. I hit enter. Now select all the data. I'll grab the data. Ignore that little error. Look at my surface now. And now you can see the excluded areas are what's underneath those building footprints. Okay. So now let's turn everything back on. And I'm going to now freeze the boundary, the break lines, and the points. And when we come back after lunch, we're going to look at another way of evaluating these surfaces. We saw it in the 3D viewer. That was very handy, but there's also a couple of other quick ways I want to show you about as well, and they're good for comparison's sake. So we'll do that after lunch. It's time for our lunch break. So it's a quarter till 1 o'clock East Coast. So we're going to come back at a quarter till 2. Any questions before we do that? Everything good? All right. So I'll stop our share. Well, I neglected to turn the recording back on when we first started. My apologies there, folks. All right. So it's now back on. All right. So the way this is working and the way it's done in terms of that dash pattern and the way it specifies line type scaling, there's a little bit of a sort of a different school of thought between players here. And in the old days, when AutoCAD couldn't do line types well at all, uh, people like Carlson and other specialty software coders that used AutoCAD, they had to write their own line style controller. So they did it in a different fashion. Well, now we have these two variables. One is called, actually three, one's for paper space, but MS LT scale stands for model space line type scale. That means, do you want the model space to show and reflect the actual line type scale? Now, when I came up here to set my settings and my drawing setup, and I changed that scale to 20, it changed this to 20, which is artificially done. It's to handle the Carlson line type. So I set it back to 1 on purpose, separately from the 20. Now that I've got my MSLT scale set to on, I now need to set my LT scale set to 1, which I had already done. And now I have to regenerate the drawing. So I'm going to REG for regenerate, REA for regenerate all. So I'll do that. And let's see, did I set my LT scale on? And then my LT scale should be set to 1. Now regen all. Huh. I just regen, redraw. All right, there's something about going through. Let me switch layouts and back. It's not. PSLT scale is also on. How about MSLT scale off? All right, let me see what this is set to. Line type scale is 1. Select similar. I'm going to come up here and change this line type scale to something different and then set it back to 1. Wow, I don't know why. Did not take my layer definition. Contour and contour 2. I gotta wonder if loading the line type is sensitive to that setting. And then do the same thing for minor. Let's reload contour 2 and choose contour 2. All right, so they now have been done. Let's select similar. Let's set our line type to be continuous. And now set it back to by layer. Huh. All right, so there's my LT scale set to 20. Hmm. All right, well, regardless, it's just cosmetic at this point, but that's the way that's going to show up as existing contours. Now, let's design and construct a borrow pit. Okay. So what we're going to do is I'm going to go to my layer manager. So view, layer control, and I'm going to turn on or make a new layer, and I'm going to call this borrow pit. And I'll make it, this cyan color, and leave everything else the same, and I'll double click it to make it current. And I'll close this off. So I now have a borrow pit layer that I'm going to start drawing. And I'm going to just draw the outlines. And I'm going to come over here and I'm basically going to draw a shape that looks similar to this black line right here that you see in the book on page 46. That's going to be my borrow pit. Okay. And I'm basically drawing the floor of the borrow pit, and I'm going to chase the edges up to it, daylights into the ground, and I need to set my volume. Okay, so I'm going to just go to draw 2D polyline because I'll set the elevation later, and I'm just going to use the current drawing properties. I'll say okay, and I'm just going to draw, say, from here to here, across to here. Here, we'll come back to this edge, maybe to here, and then I'm going to type C to close. So that now has, some kind of a little outline. Maybe it'll work for us, maybe it won't. We'll take a look and see. All right. So what we would normally do is we would find an elevation that we might think would work, and we would change the elevation of that line. In fact, you could even just select it and come over here in the properties and set the elevation. But I've got a command that's going to do a lot of this stuff for us. And we're going to use that right now. So we're going to go to Surface, and we're going to see this thing here called a design pad template. So when we do that, it's going to tell us, all right, now what is your target? What's your source of your target for your slopes to come off of this? It's a surface file, things that are drawn on the screen, or going to a specific elevation. So if I were doing the outside edge and diving down and I want to hit a flat bottom at a specific elevation, I would do that as an elevation target, but this is a surface file. And now the direction from this closed polyline, inside or outside. So in the case of us, we're doing the floor, we're going to chase the side slopes up. So it's going to the outside. Again, if I'm doing a pond, maybe I know, where it's going to be out here, and then I'm going to go down to the inside to target something. All right. So with that said, let's set our merge surface pad color to red, merge surface slope color to green. Use the color of the original surface on the slope. So this doesn't matter. So this is going to be, you're going to see these colors show up later as we do our work. Now, all of these different things down here are going to help us do this design. You can force it into cut at all times. So even if it's above the ground, you can force it into a cut condition, which would cut upward and then come back down on the outside of that to hit the ground down here. So you're basically artificially giving everything to being cut. That's one way you can do that. Same thing with fill. You can establish grade limits based on, retaining wall, back or front, or any kind of steeper slopes than the slope you're doing. If it hits a steeper slope, it will then stop at that point. Okay. You can process multiple pad polylines. Now, I'm not going to give you an example, but I'm going to show you what that is here in the help system. I think you can see it. Process multiple pad polylines. And what this lets you do is set the pad elevations for a number of different features all at once in this one command. And when you set, and you think about like maybe doing pad sites in a subdivision. So if you build a building pad, and it's got a downslope that goes down at say a 3-to-1 slope to hit the ground. And then you got another house, its next door neighbor, and maybe it's got its elevation and it's got a downslope or upslope, doesn't matter, of 3-to-1, but the two slopes would intersect. So the way you would normally build it without this option is that you would do the first pad, create that downslope, let it intersect, and then make a temporary intermediate surface that says, here's my existing ground plus house number one. And then when you do design pad template for the house number two, instead of targeting existing ground, you're going to target existing ground plus house number one, which was that temporary surface. You would then rebuild this surface for number one and two, and yada, 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 on down the line. But when you do it with the multiple pad polylines, then it lets you choose these things. First of all, you stipulate a layer that they're going to go on, and then you pick in order the ones that you want to be constructed first, then second, then third, and they go along. So it keeps you from having to keep track of all that. There's different slopes for different sides. So if I wanted a different slope coming off of each one of those sides, you can do that. Okay. So again, there's a lot of power in this command, but it's going to be really, simple for what we're doing right now. Notice you can calculate earthwork volumes. See that as an option? You can calculate the pad surface. So you can have it do all of the stuff that we've been doing manually, triangulate and contour, calculate volumes. You can have it do all of that in the midst of this whole command and come out the end. All right, so I'm going to leave those off for now. You can also use slope pad design and give it a downslope percentage, in which case if you wanted to say make sure that your borrow pit drained out to an outlet, you could put a cross slope on it of a certain percentage. In fact, let's do that. Let's use a slope pad design of 2%. So make sure we don't pond water in the back of our borrow pit. So the next thing we want to do is, well, first we're going to turn on erase previous pad entity. So if we do this by trial and error, we don't have to pick everything over and erase it. And we want to draw the side slopes, and that's just going to be little visual indicators of what they look like. And we'll color them. So blue will be fill, red will be cut, and we'll give it a spacing. We're going to say every 10 feet, I want you to show me one of those lines. Corner delta angle means when you get to this corner here, I'm shooting down every 10 feet lines, and I get to this corner and I got to turn the corner, go this way. So it's the angle that it turns as it goes around the corner. So every 10 degrees, 10 degrees, 10 degrees, 10 degrees, and then it's back on 10 feet. All right. Again, shrink and swell factors for your soil, subgrade depths, topsoil depths, all of these different things you can have it account for separately. Give it a minimum cut and fill height. You can trim existing contours inside the pad. So that would take this outline, just like we did erase by closed polyline, we said erase inside, and it would trim out those contour lines. Now, I'm not a big fan of doing that. but I'll show you an easier way later when we get around to drawing these contours separately, okay? So we'll say no for that. And then we're going to give it a pad layer, and I'm just going to type a layer here, and I'm just going to call it pit dash pad. It's my borrow pit pad. Pit pad. It's like Brad Pitt, but pit pad. So I'll say okay. Now it says pick a pad polyline. I've drawn it. There it is. I select it. Select a target surface. I want it to target my SP total. So that's my existing ground. Now, when it comes up out of here, how steep do I want those side slopes? So if I make that, say, a 4:1, and if it's in cut, do I want to also make it 4:1? Sure, I'll do that. Now we'll see, it may or may not work. We may have to change something. So it asks for the bottom elevation of that borrow pit, and it suggests a number. Read the line above it, and it tells you that the range of existing elevations along that pad polyline go from 395.20 to 404.32. Well, that's great. It suggests the lowest spot. Well, instead of 395.20, which you could see would be right in here probably, we made it even lower. We made it like 393. Yeah, let's make it 393 and hit enter. Now it wants us, remember we said use a slope direction of 2%. It says pick the first point to define the slope direction. Now I always have to do this 2 or 3 times because sometimes I should have used a negative slope, sometimes I didn't, or should have shown the direction the other way. So we'll just try it and see. So I'm going to pick the first point to define the slope. So I'm going to say come from this back corner down to this, what will be the low corner. And then, all right, so it calculated upon blah, blah, blah. It says adjust the parameters and redesign the pad. Well, I don't know yet, but I'm just going to say no. But you can see all the lines that it drew, everything is in cut. Okay, so you'll see how that looks in just a minute. So I'm going to say no, I'm not going to redesign it. So there it is. And I'm going to verify this. I'm going to select everything and look at it in my 3D viewer. So I'll go back to that. Excuse me. You spin this thing up and you can see, the one bit of the, the line work that I did for my borrow pit is actually tucked down into the ground. Okay. Now, how do I tell if that is correct? Now, remember, I did not calculate a surface for this thing yet, but you see it creates all of these little these little lines here, these 3D lines, and this line here and this line here. And if I look at that in your elevation viewer, whoops, let me go back and get that one and then view it. So you can see what it's done. And those lines out here on the side slope, they're not strictly necessary to define this surface, but they help you to see it as you're going through this process. So, this surface would triangulate just fine if I only used that line and that line. I don't need those individual side lines to actually compute this as a computed surface. However, so what we want to do is, if we want to figure out what's the volume of this borrow pit, how much material did I take away from that borrow pit surface? It's the exact same thing as we did when we calculated the surface, the total stockpile to get a volume, compared it to the base. So we're going to do a volume of this, of taking the base or taking the stockpile and comparing it to the pad itself, which is shown in the red and green lines. So the first thing I want to do is I'm going to isolate the layers that those red and green lines are drawn on. So I'll go to View, Isolate Layers, which is right there, also on the toolbar. So I'm going to pick one of the green lines, one of the red lines, and then hit Enter. And now there's what will become my borrow pit surface. Right now it's just a bunch of 3D lines. Okay. So let's build a surface. Everything's done for you already except giving it a name and drawing the contours if you wish. So I'm going to go to the surface menu. I'm going to triangulate and contour, but I'm going to make sure that I turn off drawing the contours. I'm not going to draw them yet. Just going to look at it. I'll go back to template and I'll make sure I turn on to write the file, and I'm going to select and give it a name called borrow pit. I will use inclusion and exclusion areas because there's my inclusion area. It's already done for me. Okay. Ignore any previous, and I don't need to densify these break lines, excuse me, because they're already done every 5 feet or every 10 feet because of the polyline spacing. Contours are off, labels are off, no filtering. I'm good to go. I'll say okay. Answer my prompt. Select the entities which is asking for the inclusion perimeter, which is this this outside line. I hit enter to finish that. Any exclusions? None. Now, what do you use to triangulate? Everything. Okay, boom, it's done. It built a surface. We can see it right here. Turn the shading back on. And you can even see, let's turn the visual exaggeration back down. Let's display the contours. Now there is the slope. You see that contour? So the slope drains down to this direction. And it turns out that I lucked out that I picked the right direction to draw the line. But if I had looked at that and it looked like it sloped backwards into the top of the screen here instead of down toward the front of the screen, then I would just go back and redo it and change the direction. But it looks like I managed to make it work. So that's a 2-foot or 2% rather cross slope from the back corner down to here. And everything else is it's climbing up out of the ground. All right, so that looks pretty good. And I can even, let's compare that with the stockpile top, and you can see it's there. There's my borrow pit underneath it. It's completely submerged. Let's go to the surfaces here. And for the borrow pit, let's pull the opacity down a little bit on that so you can see. Oh, sorry, wrong one. Although I think it applies to both, but I'm going to do this one. And so I can see through it. So there now, oops, a little too much. So there now I can see through the material on the top down to the surface underneath. That would be my borrow pit. Now notice I also looked out, I didn't run off the edge of the of the stockpile surface when I came back out of the ground. If I had gone down too deep, a 4-to-1 slope may never have, it may have been off the surface. And you'll see things like that. And all you got to do is just, pull the pond edge or pull the pit edge in from the edge or steepen up the slope instead of 4-to-1. Maybe try a 3-to-1 or a 2-to-1. All right, so you set this opacity back because I always forget it. And we'll exit. All right, so there's that. So how much volume do we have in our borrow pit? So let's go to the view menu first, and let's, right below isolate layers, let's choose restore layers. So it's going to put back those existing contours in the boundary. So let's compute the volume. we'll go to the surface menu and we will choose volume by triangulation, and we'll use two triangulation surface volumes. What's the existing surface? That's my stockpile total. What's my final surface? That's my borrow pit. Any inclusions or exclusions? Now, I could say only use this inside boundary, but it only goes out to the edges that have defined data in the surface. So there's no reason to have to do that. I can just hit enter and enter unless I wanted to restrict something with a smaller look inside what's already there. Again, set my cut and shrink. I'm going to not check these tons because right now I'm just using like limestone tonnage. So I'm just going to do this. No shrink and swell. I'm going to say, okay, here's my numbers. Let's see. Come out here, set it down to the right and exit that. And so I've got basically 2,200 yards of cut to get down to that surface. So I've now created a borrow pit that's 2,264 cubic yards of material. Well, what if I needed 3,500? Now, the overall stockpile is only 3,500, but you can get the idea. Maybe I can go deeper and get some more. So how would you adjust this to get, or let's say maybe it's too much. Maybe I only need, say, 1,000 yards. Well, so I didn't need to excavate my stockpile this deep. That's a better example. So what would I do? And look at this report, and this is going to help you change that design. If you look at the next little block down, it shows you the areas. Okay, it's in cut and fill. And then this block right here, let me load up the editor. This block right here, where it says the average cut depth and the export volume, the elevation change to reach balance. That means right now it's at 2264. And to make it equal 0, then I need to change the elevation by 4.6 feet. So if I were to raise my pad 4.6 feet higher, my cut and fill would match. Okay. The volume change per 0.1 foot, it computes as 49.3 cubic yards. So if I now have 2264, so I'll take that number, 2264, and I know I need 1,000 yards only. So I'm going to take 1,000 out of that. That leaves me 1,264. That's what I need. So to get to 1,264 from 2,264, I need a, shoot. I'm sorry, not to get to 20, to get to 1,000, let's see, 22, I need 1,264. I need to take 1,264 yards out of this material, which means that's how many cubic yards I need to reduce this by. And since every tenth of a foot is 49.3, if I put 1,264 and divide that by 49.3, that means I need 25.6 tenth of a foot, if you will. So if I raise it by 25.6 tenths, I should clear, wait a minute, no. Yes. So if I take that, I know I needed to get rid of 1,264 to get down to 1,000. So if I do that to move it by making the 1,264 adjustment in 49.3 chunks, I need 25.6 of those chunks to equal that 1,264. So that means instead of 25.6, if I raise the site 2.56, because I'm going from a tenth to a foot. So if I raise the site 2.56 feet, that should get me closer to that 1,000-foot requirement. Okay. See how that thought process works? So what we would do, get rid of this now, is we need to raise that thing up. So there's a couple of ways we can do it. We already have one set here. We could just pick the whole thing up and physically move it up 2.56 feet. Or we could go that same amount and just go back to redesign it. Now, here's what happens if you raise it up. If you raise the whole thing up 2.56 feet, then all around this outside edge, you're going to have a 2.5-foot vertical drop down to the ground. So that's not really a very practical example. So what I would do is I would take this 3D line, and it's got elevations at all these different points. But I would raise its elevation up that 2.56 feet. And I would say, let's go to edit, change elevations. So I'm going to change this either by a differential or set to an absolute. Well, I want a differential. And I'm going to say, okay. And so it wants to know what differential I want to make. So I'm going to make it a 2.56. Might as well use the number we had in the head. And yeah, ignore 0. I'm going to select that line and that line only. Okay. So select another line. I don't need to. Now I'm going to isolate my layers again. And I'll just pick one of those little pads. So there's that layer. And here's what results have happened. If I look at this in my viewer, see what I did? I just raised that pad up 2.56 feet. Now I could go through and clean all those things up, etc., but I'm not going to worry about it. So what I'm going to do is I'm going to erase everything except that raised line. So I'm going to choose Edit, Erase, Select, and ask me to select the entity. So I'm going to click and drag a window, but I need to remove that interior line. So I'm going to type R to remove, and I'll select that one, and I'll hit Enter. Now I've got just that as a line that's moved up 2.5 feet. So I'll now go back to restore my layers, and I'm going to run that command again, surface design pad template. And this time, and again, by the way, when it's set 4:1, that's because I had this ratio set. You can do it as percentages or degrees or whatever. All right, so I'm going to do this like this is now. I don't need to erase those now. And so let's try this one again this time. So I'm going to say, okay. It says pick the pad polyline. I'm going to pick it right there. I'm going to use the 3D line instead of setting an elevation. And what target is my SP total? 4:1, 4:1. Oh, now it's still going to ask me that. So 395, we had 393. So 393, 2.56 plus, that's 395.56. So 395.56. So it's going to be slightly above the ground. Pick the point to define the slope from here down to here. Redesign, nope. And there we go. So now you can see it's just a wee bit of fill right in there. Everything else is in cut. And now let's compute that surface. So I'll isolate, select the layer, triangulate and contour, keep the same name, It's already set for my borrow pit. I'll say, okay. I'll choose my interior, my inclusion, no exclusions. I'll grab it. Uh-oh, I've got some wee tiny little differences. I'm gonna ignore those, I think, if I zoom there and zoom in. Some of that stuff got very slightly out of whack. I think because I started with the 3D. So let's go back here to, I'm gonna erase by layer, clear that, select from screen, erase my pad. Clear, let's restore my layer. All right, we're back to that original surface, design pad template. Everything good to go here, and we were going to be right here, targeting the total 4-to-1s, 395.56, I think we used. And we started back here and came this way. Just parameters, no. All right, so now there it is. Isolate. We triangulate. Yes, overwrite, pick the inclusion, no exclusion. Now we grab everything. There, it's done. Again, a quick trip to verify it. And that looks good. So you can see a little bit of fill right in there. Everything else is there. And we can restore the layers now. Compute our volume. So volumes by triangulations, 2 surfaces. We start from the SP total. We go to the borrow pit. No inclusions, no exclusions. Say okay. And now you see I've got 1,128 yards of cut, but 2 yards of that I got to use for fill. So I got a lot closer to being 1,000 yards. I could live with that. So that's 1,100 yards basically. I could still raise it. See, 40 yards every 1/10 of a foot. So if I wanted to raise it up to get, so 2.5, so 0.25, if I raised it another 1/4 foot up, I could get even closer. Now, that's good enough for what we're doing. We could call that done. But let me show you something else that if you do not have, let me see if you guys in California have this. If I go to construction, do we have, here's your design pad. You have that same command, but you don't have this one in civil. Do you guys, Scott and Sarah, do you have the civil module?
Yeah, that's what we're,
You do have civil. Right? So what we just did there by adjusting that is basically a trial and error. And we looked at the reports and we changed things, went back to the drawing board and reset them so that we could adjust them. But if you have civil, I'm going to switch to that. Now, I'm not trying to sell you civil, Joe, because I don't know how many pads you design, maybe not a lot. But here's a nice tool because in conjunction with designing the pad, you have an edit command as well. And it's on the surface menu. And see where it says design pad template? There's edit pad template. Let's see what else is where it might also be. Command search, edit pad template is only available in civil. Okay. So if we run that command though, edit pad template, it asks you to pick the pad polyline. So I'm going to pick the pad. So it doesn't matter which one I use there. And it reads that I used a 4-to-1 cut slope, a 4-to-1 fill slope. There's my pad elevation, 395.56. It says no volume right here because I haven't changed, but if I hit process, it's going to calculate that volume. So there's those same numbers, 1128, 2.2. And their surface, SP total. So you can set a different surface if you wish. But now, one of the things you can do is let's just move the pad, for instance. So I pick that button, it says pick a start point. So I'm going to move it a little bit, say off of that back wall there down this direction. Let's do something like that. Okay, I've now moved it. When I hit process again, it's going to redesign all that stuff up and come up, and now it has a different volume. It's got 1029.4. Okay, well, okay, so if we said, well, maybe we need to be not quite so close here, I'm going to bring a road in. So if I want to move a vertex, I'm going to select this vertex here, and I'm going to drag it up this direction a little bit to give me a little more room. I can reprocess that. Well, now I've got 995. Well, I'm even closer. Don't need to be necessarily, but let's do, you can rotate, do all kinds of stuff. Let's move this vertex. We'll move this one up here as well. I think those are okay back there. We'll reprocess. Now you can see what you've got. Now I'm at 1058. Let's maybe change this pad to 392 and process. And now you see, well, I've got 2,500 yards because I dropped it, made it lower. But here's something that's really helpful when you're doing this is if you want to reach that 1,000 yards, you see this balance. If I do balance, for instance, it's going to just come up here and get a balance. I'm going to answer my prompt. No, I'm not going to optimize that. So now it says, okay, so if you raise it up to 398.7 at the front corner, it's only going to cut a little bit in the back, but it's going to fill some in the front. And that's going to give you a volume you can see up here of 253 yards of cut and fill. However, balance, I'm going to do that again. Balance is not necessarily a zero because I have a target. I want to be able to carry out 1,000 yards. So I'm going to type this number here as 1,000 and say, okay, and let it go through. Now you'll see it shift after I answer the question down here. You'll see it shift as it tries some different things. And so now it's found that location, this elevation, close enough. That gives me 996 yards of cut and 1.9 yards of fill. Let me do that balance one more time. Let's turn this down to, instead of every, let's go to the nearest 1 cubic yard. Whoops, I may have it may have reset to 0. I've got to see if it did or not. Yeah, it did. Whoops. Let me balance that again. There, to the nearest yard, and now export 1,000 yards. Say okay. Answer the question. So now it gives me 1,001.7 yards of cut and 1.7 yards of fill, exactly 1,000 yards. If I build it at this elevation down here at this spot, and it has a 2% slope upward. Okay. Once that's done, I can now write the 10. So I could go through the same process I did by isolating the layer, select and do and blah, blah, blah. I'm just going to let it generate it for me. Yes, I'll replace it. It's now done, and I'm done with the edits. So it saves me a lot of effort if you get into doing that type of design where you're needing to come up with things like that. Okay, so the civil module is very helpful with that edit if that's what you need to do. So now we've got an existing stockpile, we've got a borrow pit. So, and right now we're showing these drawn 3D lines. We don't really need to see those. So what could we do? I'm going to freeze that pit, or the pad layer. I'm going to go to view, freeze by pick. I now see that outline after I've made my changes. So that's the actual floor. I may leave that in there just to use for reference. But we've got these two surfaces and you saw me load them up together. What if I wanted to compute a new surface after I've cut out the borrow pit? How would I go about that? And the answer would be, if you're doing it manually, you would draw that outside footprint. You would get rid of all the points that are inside it and only use the outside points and use those as break lines. But we have a tool to handle that as well. We're going to go to surface. Let me go back to survey for poor Joe. So go back to survey and let's do this. Triangulate. It's on the surface menu and it's called triangulation file utilities. And what we're going to do is merge one into the other. So the first thing to do is to load up the base 10 file. So I'm going to choose this button, load the 10 file, and that is my SP total. There it is. And this is much like the 3D viewer. You've got the shader, you've got the view rotation, that sort of stuff. And now I'm going to go to the next button down here. So I go to the next screen. Now I'm going to add in my borrow pit 10, and I'll go ahead and shade this again. But that's another term to sort of avoid. And this is also, resizable, just like the viewer. You don't want to say, come over here and choose this button. You want to add a 10 because what that does is it adds a value to that 10. So we're not going to add a numerical value. We're going to merge a 10 right here. So if I merge a 10, I have to tell it, first of all, how I want to do it. So I'm going to say my second 10 is inside the current 10 outside boundary with a transition, or its current 10 is inside current 10 outside boundary with adjusted elevation. Remove from the current 10 where it overlaps, recombine, repair the gap. That would work either one. Either number one or number three would be fine. And I'm going to use these colors down here, set the color of included and excluded triangles. You'll see those later on. And I'll say, okay, go ahead. It's going to ask me for that surface. There's my borrow pit. Off I go. And now there is the resulting surface, but showing you as, two different composites of how it did that. Okay. So once I've done this merging, I have to output that as a combined surface. So I'm going to make sure I've got the inside, the borders, and the outside, and I'm going to choose Save As. And when I do that, I'm going to call this my SP-pit-merged. Okay, so now I've got a total. I can exit that, and I have a single surface file that I can view. SP-pit merged. There it is. And there's the way the contouring would look if you were to build this surface combination. You see the different shadings. That's how that color choice. It didn't actually stay red and green, but it did keep, different. So that's now a single surface. You can again remember we had the quick profile tool, and I'm going to say my first surface is going to be that merged. The second surface is going to be the total. Say okay, and let's look across and see what we got. And there you can see as I go one to the other, go across the side, the white one that I'm tracking, that's my merged surface. And all that red material, the red line above all that is where it actually continues. Let me adjust. I'm going off the edge. There we go. So there now is the that would be the footprint of that cut, and that material in there, that's the cut along that line that I need to take out of my stockpile. All right, and you can see it as I do the adjustment in real time. As I drag it around here, you can see, where all that comes from. And again, save, draw, do all those kind of things. And then let's exit. Okay, so there it is. Now, again, remember, this is the floor. This is not the outside top. It's the floor of that as a reference. So what could we do if you wanted to create a grading plan, which shows existing contours and proposed contours? So right now I've got my existing contours, and if I wanted to generate this as a grading plan, what do I need to do to build this surface? And what would I do? I just draw the contours from that file, right? And so I could go to my surface menu, contour from tin file, and I'm going to use just the borrow pit. I don't need all that other stuff because it's still existing. And I'm now going to change the layers, and this is going to change from V dash surf to C dash surf. And that's all the changing I'm going to do are those layer names. I'll say, okay, let's see, I'm going to, don't even really need to label them at all. Let's just leave that off and say, okay. No inclusions, no exclusions. And there is the grading plan with those contours. And if you can change those layers, there's my, I'm going to make these but keep them. Actually, I want to make that 254, make this one white. And I'm going to give it some weight. I'll make that one 0.3. And this one, actually, let's make this one so 0.3. Let's make it 0.4. All right, so there we go. And so there now is the grading plan. And you can see here's the contour that goes around the interior. This one also goes around the interior, but you can also see if I were to, let's freeze that. So here's my grading plan in and of itself. Okay, and I'll back that as well. But you can see how they tie, how these design contours tie into the existing contours. I actually need for that to show up a little better. Make it 0.3. There we go, a little better. All right, so that's my grading plan. That's what would take to build that. And you see they all tie together. Now, what if you wanted to trim out the existing contours within the footprint of those proposed contours? What could you do? As a rhetorical question. You could draw the boundary of that pit surface and use that as an exclusion polyline, or you could even draw the boundary of that and use that as a wipeout and put it over top of the contours, but underneath everything else. Let's see, what else could you do? You could simply draw the contours of the merged surface, but you wouldn't see the differentiation of the two. But if you wanted to cut out these existings as they go underneath, the easiest way of doing that, and I'm going to go to Surface Manager, and I'm going to set my SP total as my current. I'll take my borrow pit and remove it from the list, but keep the things that are drawn. Say done. I think this will work for me. So if I then go to Surface, Contour from tin file again, and this time I'm going to redraw the stockpile contours, but I'm going to stop. Actually, I need to, before I do that, I need to go to Surface, Draw Surface Boundary. And I'm going to do the boundary of the borrow pit. Okay, so there's the edge of the borrow pit. So if I then go to Surface, Contour from tin file, choose my SP total, and remember here I've got use inclusion exclusion is on. I also want to erase previous contour, the current surface only, and I hope that keeps my other ones, we'll see. Select the inclusion, which was that outward. I didn't need to select it, but now my exclusion is there. Oh, okay, it did it, but let me do it one more time and reset the layers for us. I forgot to do that part. Put this back to the V layer. Labels, we will label this time. V and V. All right. Now, no inclusion. There's my exclusion. All right, so there we go. We now have, and let me freeze this interior boundary a little bit. Let me see. No, crap. It's still not erasing things correctly. All right, so let's erase by layer. I'm going to clear that. Select from the screen. And it's going to get rid of all of them. Okay, now this time let's go back to draw. Contour from tin file. Let's choose my total. I'm going to change that erasing to not do that. It's apparently not keeping track of it right, or I'm not. That's probably me. So I'll say, okay, inclusion is what it is. Here's my exclusion. That's what it is. There's now my contours. You see the labels, 400, 395. I'm going to repeat the process. Contour from tin file. This time I'm going to use the borrow pit, and I'm going to not label, and I'll change my contours now to be C for my proposed. Say okay, no inclusions, no exclusions, and there it is. And you can see, you can't tell very well, but that's a heavier line than this one. That's your index, and you see how it comes around here and it ties to that. Now I no longer need that necessarily. You know, there's your grading plan right there. Okay, now I can put back that as a reference. I will thaw back that and let me match those two as boundaries, just for eyeball reference. Okay. So next and last step that we wanted to look at was to put in a road it's going to create that road for us. All right, now keeping in mind, and we're not going to get into it and show it, but these civil tools have a tremendous amount of different road design tools, including setting cross sections and subgrade thicknesses and curbing and all kinds of stuff there. We're going to put in a center line and we're going to lay it on the ground and we're going to design a profile for the trucks to travel on and we're going to land it in our surface over here, okay, and see what it looks like once we put all that together. All right, so we're just basically doing the top. So let's draw us a line. So I'm going to draw a line. I'm going to sit on the surface, or I'm going to choose draw 2D polyline because it's going to be a center line. It's going to be the alignment. I'm going to uncheck the current and I'm going to put this on a layer called C-road-CTRL. No, CTLN, center line. Okay. Set my color to be by layer, which hasn't been defined yet. I'm going to say, okay, and I'm going to start over here. Coming in, I'm going to say, I'm just going to pick a point. I'm going to do this for a reason. I'm picking over here, and I'm going to do Shift, right click, and set perpendicular to that line. So the reason I did that is so when I offset the edges, one's not going to be sticking off the surface. I'm now perpendicular to that line right there. But how do I now continue this line? So I'm going to say from here, I'm going to extend that line out here. I normally do it by grips, but here's another command on the polyline toolbar or under edit, extend. We're going to just lengthen or extend by distance. Let's see if I lengthen, let's see what it does. Dynamic DY. So if I check this, unable to use that selection, cannot be linked. Okay, fine. So let's go back to edit, extend. Let's do by distance. That's the one that we normally use. Pick an arc, a line, or a polyline. So I'm going to pick near this end, not that end, just nearer this end. So now you see I've got a little arrowhead telling me, okay, so here's the direction I'm going to go, but look at all those options down below. I can choose any one of those things, and I'm going to just type the question mark as the option to show you, and I think that will bring up, nope. That's info. It used to be just a question mark, so let's type H for help. So here are all the different options. If you just type a number, that's the additional distance to draw a move. You got angle chains, alignment, bearings, close, draw. You can turn left and right. You can do all of these different things, or you can type T number, which means go from whatever it is to a total distance of whatever you type in. So I'm just going to type in, I'll exit that. I'm just going to type in a number and I'm going to say start from here and come out here. I have no idea what that is. Let's say 100 feet. Well, that was way too much. Let's cut that back to 50. We went 100 feet out from what it was. So we're about, so let's say a total now of, let's say 65. All right. So that puts us right there. I'm trying to think how I'm going to draw this. Let's make it a T of 40. I'm going to T of 50. That's a little better. All right, that's good to go. And I'm going to hit enter to finish. So I've now made a 50-foot tangent coming in off my entryway. Yeah, let's do this. I don't even really need to add a second curve. I'm just going to slide this down this line a little bit here. So I'm going to move this. I'm going to select it and I'm going to choose move. I'm going to move. I'm going to hover there. You see my endpoint snap comes up. I'm going to go from that endpoint. And now I'm going to come up here and grab my nearest snap, which is right here. or shift right click. And I'm going to come down here a little bit further down the hill so I'm not quite so close. I can make a smoother turn in. Okay, no problem. So now what I'm going to do is I'm going to draw another 2D polyline. Same conditions, and I'm going to start out here somewhere is about, and I'm going to say perpendicular, go back to that floor polyline. So that's now perpendicular to that. So I have to come from here to here and make that as a change. Well, that's a greater than 90-degree turn. So I'm going to draw sort of a intermediate turn in between there. That's not this steep and not that steep, but I'm going to go from, say, oh, somewhere here to here. And this, let me move this down, just scope. I've got this done wrong. Let's see if I'm going to turn it like that. Yep, and then we'll add a vertex up to here. Okay, and then we'll just move this back here. I'm just grabbing the grips and snap editing. So that's going to be my road center line, but I need curves and I need to connect these pieces together. So I've got a piece here, a double piece there, and a piece here. So to connect those together, I'm going to go to Edit, and I'm going to Join Nearest, and that's also on my Polyline toolbar. You can specify an allowable gap, but I want to directly connect the endpoints, or I'm going to fill them with a radius of 0. So if they don't quite meet, it'll extend out to their intersection. I can set any kind of filters down here for elevations, layer names. So I'm just going to select this, this, and this, hit enter. And now when I select it, I see it's one continuous polyline. Far so good. Let's quickly go to centerline and choose polyline to centerline file. Let's call this our Hall Road. Select the polyline that represents it. There it is. Everything's good to go. Hit enter to finish. We're done with the center line, but we need to put the curves in. So we need to go to the editor, and I'm just going to double click it to get to the editor up, and I'm going to fit some curves. I'm sitting here. I'm going to fit a curve of, let's see if we can get as much as a 35-foot curve radius in there. That's a little too little. Let's make it 50 feet. All right, so that's better. We'll come down to this line and let's fit a curve. And I think maybe 75 feet because we're so, oops, too big. Let's make it say 40 feet. Oh, that's really, make it 25 feet. I guess because it's so gradual. There we go. We'll come down to here now. We got to fit a curve in there. Now that's going to be a tight curve. And no, we wouldn't normally we would do a little better design than that. But here's what we got. We'll save, we'll exit. There now is going to be our roadway in. Oh, I see what happened. Let's undo. Let's fit a curve of 50 feet. I think what happened was all of the edits that I took shortened up those tangents. So let's fit that curve in. That was a 40-footer, I think. Yeah. So if I shorten that radius up to be 25, but I'm going to hold the PC. No, let's hold the PI. There we go. So now it didn't shorten the length, I think. We'll fit this curve of 25. Hold the PI, just make it 15. Now save and exit. And it's still, I want to keep this actually a little further down this way. And I want to extend that and then pull this back to the intersection. All right. Yeah, one more time here. Let's try it. I double click that. I'm going to fit a curve of, let's say, 40 feet. I'll come down here. I'm going to fit a curve of 25 feet. I'll come down here and fit a curve of 20 feet. There we go. Save and exit. Now there's going to be my center line alignment to get into my borrowed pit. Okay. So what do we do with that structure? How do we make a road profile? How do we know what the ground looks like underneath there? So we have to create a profile of the ground surface along this alignment. So I'm going to go to the surface menu, and down at the bottom are my profile tools. So I'm going to create a profile from a triangulation surface. I'm going to look at my total surface. It's going to be a roadway, and I'm not going to do any of these others here. I'm going to specify OK. It wants to know the profile file to write. I'm going to call this Hall Road-EG for existing grade. So the polyline should have been drawn in the direction of increasing stations. Choose either a centerline file or select the polyline. Well, I'm just type CL to pick the file, and it's going to read the mathematics of that. It did it. It created it. It's there. I now have a profile, which I can look at in my profile editor. All right, here it is. That is my existing ground along that line. So I need to design a road profile as well. So I'm going to go to surface down in here, and I'm going to choose, I need a profile editor. So I'm going to go to my profile editor. Excuse me, and I'm going to go to a new profile, and I'm going to call this Hall Road FG for finished ground. And while I'm in this blank editor, I'm going to come down here and make sure it says to road. I'm going to use a reference profile and a reference centerline. So the reference profile is that existing grade that I did before, and my reference centerline is my Hall Road centerline. So it ties the stationing to the centerline, and there now is the existing ground. So I need to start putting in some elevations and curves and such like that. So I'm going to start here at station 0 back here, and I'm going to go all the way here to the depth column, and I'm going to type a 0. So that sets right on the ground at that point. I'm going to do the same thing right here at 2 at this second station. And I see down here below my center line goes to 1 plus 48.4145. So I'm going to say 148.45. I'm going to set the depth at 0 as well. It must be off. Yeah, it says it's outside the range, so 4-1. Why is it not? 148.41. 148.41. There we go. Set that depth to 0. Fit. Ah, I see, because that doesn't go quite out to that distance. Let's just set this value to 148. Point 4. Oh, good heavens. Road 0. I need a depth. Save changes. No. Let's try this again. Repeat. Profile edit. New FG. Let's load a reference center line, which is Hall Road. A reference profile, which is Hall Road EG. So that goes to 1 plus 48, 4096. So let's just take these to 0.4. All right. So station, depth of 0. This station is 148.4, we said. A depth of 0. All right, so there, if I were to grade this flat, it would come to that. And right here in the middle, you see as I'm tracking, it shows me that I've got 2.1 feet of cut. That's fine. But I can add a couple of PIs. If I want to add it right where my crosshairs are tracking, right in there, it's like at 25 as my station. So I'm going to come down here and I'm going to insert, I'm going to add a row at 25. And I want that slope to be, slope is not reading very well. Let's see that slope. Let's see that ground elevation. It's like 395.7. 395.7. And I want to make that into a, let's make this at 396. And let's make a vertical curve length of 25 feet. So it's going to do that. And now I need to come back. Need to make that 0 again. So now I've got my curve in and I want to come down and put another PI right here at 125 at 395.5. So I'm going to sit here and say add a row. 125, 395.5, 395.5. At 0. There we go. And so at that, and I get rid of that row, and at that station right there that you see the marker, let's make a vertical curve length of, let's say 20 feet. So terrible road design, but you get the idea of what we're doing. Okay, so I'll save this and exit. And now I've got those two profiles, and they make this roadway center line go from back here to up here along that line. Now, if I make this center line file, go to my layers, I've now got a C-road center line. I'm going to make two more. I'm going to make a C-road EP or edge of pavement. I'm going to make another one called 3D, or let's see, not 3D, but C-road C T L L N centerline dash 3D, and one more that says C road CTLN 3D. All right, so far so good. Oh, it's not centerline. C dash road dash EP dash 3D. That's what I meant to do. We'll keep that white. We will load up a center line file, or line type rather, and we will assign that accordingly, and we'll keep it white. The edges of the pavement right here. C-road centerline, C-road edge of pavement. We'll keep it continuous, but we'll make them, let's make them green. That'll be the 2D. And then the 3D part, my center line, I'll make it magenta, and the road edge of pavements, I'll make them also magenta. Okay, now I'm doing that to be able to visualize some of this stuff. The center line needs to be center. Okay. So now if we want to make a road with, say, 10 feet either side, so I've got a 20-foot haul road. Since this is just a standard two-dimensional polyline, I can do a standard. So I'll edit, offset, standard offset. I'm going to go 10 feet away. So I'll type 10, specify the entity. Now, which side or both? So I'll choose both. All right, so there's now my road for my 10-foot. And I'm going to select these two lines, and I'm going to change their layer to put them on C road edge of pavement. So there's now the roadway edge of pavement, all in 2D. Now, how do I get the 3D on there? Is I need that 3D center line to be able to draw right where it is in relations to this 2D. But right now it just exists as a file. But if I go to my surface menu and down here on my profile business, I can say where the command there that says profile to 3D polyline. That's what I want. I want to create the 3D polyline on the drawing. So I'll choose profile to 3D polyline. The layer name is going to be C road centerline 3D. And I'm going to choose a roadway type of curb definition, pick the center line file. So CL is haul road. And what's the profile? Well, I'm going to use the finish grade profile. All right. And so now there it is. So if I look at these things in my 3D viewer, I can see, the white center line was down at the down at 0, and this one is, as you can see, it has elevation. So that is truly a 3D. Now I've got that stray point that keeps generating down there. There we go. So now, just like I did these road edges here, how do I get the 3D edge of pavement? And we need to do that as an offset. But if you try to do a standard offset, it's going to tell you it can't offset that because it's 3D. So Carlson has a way of doing that with, go to edit, and we're going to choose 3D polyline utilities, and we're going to offset a 3D polyline. And we're going to choose this method by interval. So it's going to ask us a horizontal amount and a vertical amount. So if I want to go by interval, I'm going to say okay. And it asks the questions. Vertical / horizontal offset amount, that's in angle brackets, that's my default. So I'm going to go 10 feet away horizontally. Vertical offset amount. All right. So I don't know what it is. I do know I'm going 2%. So it's going to be, 0.02 or whatever the 0.2 feet, but I can type P as an option there for percent. And I'm going to go down at a -2%. And I'm going to select a polyline to offset. I'm going to pick that 3D polyline and I'm going to go both sides again. So now it's done. I would enter to finish. I now have 3 edges and a center line that's slightly higher. If you look at these starting vertex locations, keep your eye down here in the status bar. When I hover in the edge over here, it is at 393 or 394.99. Right here, it's 395.19. Here it's back to 394.99. So you see it did, in fact, cross down. And again, another quick profile, this time for screen entities. And if I just look across here, you see there's the crown of my road. All right. So far, so good. Now, how do I tie that into the ground to make these edges fit? Remember, we did the design pad template for the borrow pit. Well, you can do a design pad template on these 3D lines as well. And they don't have to be closed polylines. Okay, so its only difference is because it's not closed is it's going to ask us which way to direct it. So we'll go back to surface, design pad template, and this time, again, going to the surface, it says slope direction from a closed polyline. Well, it's not closed, so we're going to just, it doesn't have any effect. I'm going to uncheck to use a slope pad design. And I'm going to change its layer now. I'm going to call this one cut and fill. I'll put a pad there on there, and so I'll say okay. And it says pick the pad polyline. Well, I'll pick this one right here, my 3D. Pick the target surface. Now, remember, I could go to this, but if in case it were to go over and hit part of this, I want to make sure I use that merged surface as my target. I'll say open. And let's keep it 4 to 1s would be fine. And I'm going to go to, now it asked me to pick a side. I'm going to go to that side. So there's where it would be. It's got to cut down to get to the road. So I'm going to say no adjustment, no redesign. I'll repeat the command. Everything else exactly the same. Hit OK. I'll pick the opposite side and go to that merged surface. 4 to 1, 4 to 1, and I'll pick this side. And there you see, here's the point, they're off the surface. You see, and it gave me the warning, and it's trying to fill, and it's too high up in the air. So I'm going to say, yes, I will redesign that. So when I'm in fill, let's go with a 3 to 1 and see if that helps. Cut will stay in 4. No adjustment, no offset. Okay, now it still says I missed a point, although I don't see it there. So I think I'm in good shape. So I'll say no. Okay, now I've got a road. I'm going to isolate my road pad. I have these individual pieces for these individual surfaces. So if I were to generate a surface here, I'm going to triangulate and contour. Make sure no drawing. I'm going to write the file. I'm going to call it Hall Road dash left. Inclusion, everything's good to go. Boom. So there's the inclusion polyline. No exclusions. Now, which points or which things to do? I'm going to make sure I get all of these things. Let's see. I don't want any from the other road here or the other half. That'll do. And crossing brake lines, too little to worry about. All right, now I'm going to do that same thing. I'm going to change the file name from Hall Road left to Hall Road right. Say okay. Choose that. No exclusions. Making sure we get everything here without getting parts of the other road. Be done. And it wrote it. Now, to look at those two files just to make sure, my Hall Road left. There it is. I'm going to add to it my Hall Road right. There it is. You know what I didn't do? All right, so I've got those individual roads. Those are the fill banks. Okay. I really didn't need to do that separately. If I restore my layers and let's isolate the road and the center line. That's really what I should have done. Just put it all together. Now, I don't have end caps on here, so I'm going to draw and I'm going to put this on C Road edge of pavement 3D. And I'm just going to close up this gap. Do the same thing here. Yeah, that should do. Now, I'm going to shrink wrap that. So I will draw, shrink wrap, close line work. I'm going to put that on C dash surf dash C dash topo dash surf dash BDY. Or zeros. I'll grab this. There it is. Perfect. All right. So now I'm going to build a surface. Just call it the road, triangulate and contour. Just call it Hall Road itself. So now we have those other ones in case we ever need them. Inclusion, exclusions, no contouring. There we go. Say OK. Select the inclusion boundary. No exclusions. Grab the data. Again, made too little to worry about. Let's take a peek at it real quick. The Hall Road itself. There it is. What are our settings set to? Let's look at our 0.5 contours just. So it looks like a nice little road design. You can see the crown of the road. depending if I get the shading to look right across the Zoom video. I don't know that I can, but you get the idea. So we now have a road. Let's restore that back. Let's go back and now merge that. So triangulation file utilities, I'm going to load up my SP pit merged as my base. I'll go next and I'm going to merge my haul road. Keep that same type. And that's what it all would look like once it's done. Now, notice up here, I've got a little slight little twinge because I've got that cut slope coming out of here and I'm meeting up the edge. So I didn't really put, I should have taken this this cross slope out on this end. I should have flared it up to meet those edges. Okay. So we can save that as total merged. Well, that's it. So without going through the exercise, what we can do is things like this. There. I want that. I still wanted got the other pad turned off. Anyway, what can happen is, and what caused that problem? I've still got the crown that's peaked, and it slides down 2%, and that sets this point right here. From this point, it goes down here 2%. Well, it's up against that floor of that pit. So what I would do is before I built all this, I would have come back here and take that little I would take this edge, and instead of that being 2% down from here, I would set its elevation to be exactly the same as this one, or actually the target that it's going to match. Okay, so that would be one way to sort of flare that out. All right, so without getting into all of that more advanced design, take a look at what you now have with their total merged package. And you see right in there, right there is that edge that I would have normally brought up to meet this edge instead of being 2% down from the crown. Okay, so if you're really, tying these things in exactly, here's another place on this side. I should have brought that edge up to there. Now, I don't think, can I adjust? If I set a point elevation, if I set that point, yeah, I would have to know that point right there. 395.92, 395.93. So 395.93. See how that brought it up? It's not exact. I mean, I would have done it more exactly. The other way. That's 396.25. So 396.25. You see, it brings that up like that. So I would have, done all that around there. So now I've made that, I'll save the changes. And we'll call it. And then verify that one last quick time. And now you can see the road goes flatter anyway, because I just tweaked it. So the same thing happens right here on the butt end of this. You see how it comes down and back up, down and back up. So I should, and like I said, the civil road design tools have tools in them that help you do all that stuff as part of your targeting. But for right now, just setting off 3D lines and offsetting them and tying them into the surface, that's a pretty decent little approach. Okay. So that brings us to the end of the day. You guys have actually earned an extra half hour for your PDHs. So, Joe, that'll help you out a little on keeping your license. Uh, so I'll give you that extra credit. So um, at that point, let me open it up to any questions. If anybody's got any particular questions on anything. Any, anybody, I know it's just a real marathon sprint, but if you'll pardon the mixed metaphor, there's a lot of stuff to get through, and that's just, setting the stage. Again, what you get if you were in the civil class, you would get into all those really advanced grading and road design tools. But you can see how quickly, excuse me, that you can accomplish some things. Oh, by the way, a couple of things I did want to quickly show you. On the surface menu, you have this surface inspector. I think maybe you don't in survey. If you don't have it in survey, there's no need to worry about it. Surface inspector, surface. Who gets it? Civil. Yeah, survey doesn't have it. All right. Anyway, surface inspector is just you set it all up and load your surfaces in a list. And then when you hover the mouse around, it reads the elevations of those spots on the surface. And if you click it, it drops a marker. Same thing that you can do on your Point Kogo. Let's see. I think what you would have to do for the equivalent thing is to create a point where you want it and set its elevation by the surface. I think we can do that. If I want to just draw a point, we'll call it 1, 2, 3 spots. And I'll say screen pick, let's see, elevations. All right, so if I screen pick a point right here, now point elevation, I can't really snap to a surface, and these are not 3D lines here, I don't think. Maybe they are. Let's see. Nope, they're not. Let's just make it 0. And we'll call it spot. And so I've got an elevation of 0 there. And what I was wondering is if I can change the elevation of that point by reading the surface. I don't think I can even do that. Let's see if I edit points, lock the points, adjust the coordinates. Translate the coordinates. Elevations. I know when I go to stake that out, if I do a radial stakeout, X and Y, a range of points to create port provision options. I wanted to use All right, let's not do that one. Let's look at cut sheets. Cut sheet. Ah, wait, I just saw. Under survey, set point elevations by surface model. There we go. So that was my total merged. Selected from the screen. If you had more than one, I just got the one. So there it is. Link the elevations to the surface model. So if that surface model will change, it will change the points elevation as well. So that way you can do a bunch of points. Let's draw locate our points. We'll just screen pick and we're going to go, another point there. Enter, enter. And we'll come back here in the back and set a point there. Enter. And then maybe set a point right in here on the center of the road. Enter, enter. And then, point here just for yucks. Enter, enter. All right, so now I got those points. And I would say simply go to survey and below cut sheet to set my point elevations by surface model. Choose my model, which is total merged. And what do I have? 1, 2, 3, 4, 5. Even though I think I've just written over top of, oh no, I'm okay. So just do my numbers 1 through 5. Yep. And so if that surface changes, they're going to change. There's 3, 95, 59, 95, 65, 95, 75, 96, 79, 97, 41. So that is, like I said, the fire hydrant approach to getting this stuff done. All right. So there are some other nuances that if you read over your training guide, you might see some extra little treatments of things in there. You will be getting your certificates. You'll get a link to the YouTube videos. Which will come. And again, I have to apologize. I managed to leave that recording paused from our lunch break for a little while. So it'll be a little missing there, but I'll see if I can't find you another one that I can point you to from another class that might pick that up. So didn't really miss a whole lot. It's all just been reinforcement of what we've been learning. Okay. So any questions to this stage, or everybody ready for calling it a day?
We're good, Ken. Thank you for everything.
You are most welcome. I will wish you well out there, Joe. Thanks for the thumbs up. And like I said, in a day or two, or maybe even the first of next week, you'll get your certificates and your links to the videos. I'll make sure you've got a link to another one that didn't have the gap in it. I apologize for that. So it's always good to see another class perspective anyway. So, okay. So with that, everyone, I will stop the share. I'll stop the recording.